Okay, morning, everybody. Hey, it is March 12th, 8:30 Pacific Daylight Time, which is my time. And I had a bunch of people from the one of the other channels called Earth Discussions. It's a great channel. If you've been over there, go check it out. They have dialogue with flat earthers, and they discuss flat earthers 24 hours a day. So if you haven't been over there, go ahead and check them out. But one sec, I got to turn off my other video here. So anyways, there's a bunch of people I know from that channel, and they decided to want to open another room, and I said I'd be more than happy to do so. And they were going to talk to a gentleman here named Ali B, who's a teacher, I guess.
Alan, you call me Alan. My name's Alan. It was just
Alan,
my
okay.
friend.
All right, Alan. Alan's a flat earther, and I guess Alan has a model, or going to explain to us why flat Earth is true.
I had a model.
Oh, you don't have a model? Okay, my bad.
No,
you don't have a model.
A Danish model.
Okay. Okay. Hey, guys, I know you have limited time here. Do you want to get something out of the way before we get into this real quick?
Yeah, sure. Hi, Ali.
How you doing? Who actually am I talking to? What's your names?
You're not going to know my first name, but you can know me as Geist View.
What you called?
Geist View.
Oh, Geist View. All right. I'll just call you Geist then. Yeah. Is that all right?
However you want to.
Is his thing flickering?
Yeah. Ali, what's going on with your camera there?
People have I don't want people to go into seizures if they have like.
I'm basically tripping out over here, man.
Yeah, sorry, right. Okay, that's to do with the. It's because I want to see if I can change my.
Yeah, if you're sensitive.
It stopped there for a second, then it started back up again.
Yeah. My whole audience is having epileptic seizures right now.
Yeah, I know. How's that? There we go.
There we go. Right? Yes, much better.
It's because that was the camera on my laptop, and it's kind of
much better. All right, go ahead, Geist.
Okay, I was listening listening to something you guys were talking about last night in ED discussions in regards to a vacuum. And one of the things that you brought up was a vacuum can't be a pure vacuum unless there's stuff in it, right?
No, I never said that. I said it would have to be empty, void of everything. Isn't that the definition of a vacuum?
Okay. I'm just trying to clarify your position. So it has to be void of everything. Okay, where did you?
Right, that was what I said. I said a pure vacuum void of matter.
Void of all matter. Where did you get this definition from?
Was that not the definition?
Where did you get the definition of vacuum to say that?
Well, I got taught that at school.
Okay, I'm trying to figure out where you found this definition at.
From school.
Well, I mean, are you disagreeing with the definition? I mean,
in science class.
I mean, a vacuum is space void of matter. I mean, I think I'd be okay with that definition.
Okay, but no, that's not how. It's like people get the terms of theory and theory wrong when you use them in different contexts.
Right, so
and I will explain. And I will explain. You are using the layman's terms of the word vacuum to mean basically absolutely nothing. But in physics, vacuum actually has a definition. And a vacuum in physics, the definition is, quote, space. Vacuum. Space in which there is no matter or in which the pressure is so low that any particles in space do not affect any process being carried on there. It is a condition well below normal atmospheric pressure and is measured in units of pressure, the Pascal.
Right. Yeah, he's just condensing that. I mean, void is
yes, but Ali's argument is because to him the word pressure.
Is he breaking up, or is that just me?
I think Geist lost all pressure at that point.
I think he lost all pressure.
Hello?
Yeah, you're kind of breaking up, Geist.
How about now?
Oh, you dropped out. You're fine now.
How about now?
Yep, good.
Okay. How Ali is using the word pressure in his terms, it means you can't have anything in outer space, because if it is anything in outer space, any molecule, any planetary body, anything to him is not a true vacuum because there's something in space. But that is not how physics uses the word vacuum. So we say a vacuum of space, we're talking about how physics defines a vacuum of space.
Correct, yes. And obviously, I mean, the density in space is about 1 hydrogen every, 2 centimeters or something like that?
Yes, but...
Or cubic centimeters, very low. So
yes, but Ali's argument is you can't have a true vacuum of space because he's talking about with atmosphere. Atmosphere has a gradients, and
right.
I think he's arguing that you need a dome to separate Ali? Are you the kind of person who advocates for the dome?
He's shaking his head no.
No.
Okay, so there's no problem with 0 atmosphere pressure in contact with 0 pressure of space, right?
Say that again, sorry.
So there is no problem for you with having 0 atmosphere pressure and 0 pressure of space, right?
No, no problem at all. It's zero
Okay.
pressure, yeah.
I just wanted to correct you on your definition of how physics uses the word vacuum. So when you're arguing with people and they're saying a vacuum is space, they're talking about the way physics is being used, how it's being used in physics to define a void of matter or pressure.
Right, so there's no pressure and no matter.
No pressure or
no matter.
sorry.
Neither or situation. Yeah.
Yeah, you can have partial vacuums on the Earth. We have partial vacuums all the time. We just call them a vacuum because they're lower pressure areas.
Because if you have nothing, when it refers to matter, it's a vacuum. But also you can have matter inside a pressure vacuum.
Yes.
And it's still a vacuum by definition.
Yes, absolutely.
Yeah,
yes,
if I put a clock in a bell jar and then suck on it.
Yeah.
There's a vacuum in that bell jar. There's a clock in it. That doesn't make it not a vacuum.
Correct.
Yes.
You agree with that, Alan?
Well, not regarding the definition, you know.
Then you're not using a correct definition.
Well, you say, right,
it's not me. Ali, you're getting stuck on. Sorry, go ahead.
Well, exactly, thanks. Because, yeah, right, okay, right. So you're saying that a vacuum can be a low pressure system, yeah, or with matter in it.
Yes.
Is that the definition?
Can I answer? Can I answer?
Yep.
Okay, it is not me defining this. This is defined by physics.
That's a physics. That's actually a physics definition, Alan.
You're repeating it, right?
Yeah, but
so
Alan, Alan, that is a definition in physics. I mean,
right, okay,
just like the vacuum and the bell jar. In the bell jar, there's a vacuum, but there's mass in there. There's a clock. So yeah, you don't have to have perfectly a space that has absolutely no mass in it to have a vacuum. Would you agree now?
Well, I got taught at school that a vacuum is devoid of all matter. Right?
Well, you're talking very simply, but
you're talking, Ali. You're talking layman's terms, like people say theory and theory.
Yeah, you're talking very, very general. I mean, you in school. I mean, unless you took, did you take physics classes?
It's definition.
Did you take?
I just told you the definition. I can find another definition. It means the same thing. This is out of the Encyclopedia Britannica. If you want, I can go to another one. If you want, I can go to the Cambridge. I can go to the Webster. They all mean the same thing.
Yep, I know. I'm not disagreeing with that, but that is so. There's two definitions of a vacuum.
No, it's one definition, but it means two different things.
Yeah, but
if you have something that has absolutely no matter within inside of it, it's considered a vacuum. But also, a vacuum is considered an area with absolutely no pressure.
Well, this is losing me, actually. That's two different definitions of a vacuum.
No, it's not. It is one. You are using vacuum as mean no matter, but when we talk about space, we're using it as in a lack of atmospheric pressure, i.e. a vacuum.
All right, so you're calling a no pressure system a vacuum?
Yes.
Right.
That's what it is.
That's by definition what it is.
Right,
Yeah.
so right, okay.
All right, so we're not really.
Okay.
I really don't think we need to have a discussion on semantics of definitions. I mean,
no, I was just reason why
physics stuff.
Yes, the reason why I brought it up. Reason why I brought it up because.
By the way, I think there's some lag here. Ali, are you on a phone or something, or a tablet, or an Android system?
Laptop.
I'm on a phone.
Oh, you're on a laptop. He's on a laptop. Okay.
Denmark. I'm in Denmark.
All right. There might be a little lag, and I think you're dropping out if people are talking. That usually happens on an Android system, but okay.
Right, 1 second. I'll put headphones on. That might help.
That might help. Yeah, that might help.
And then again, it might not. I'm using the microphone on the camera. So,
To my mind, to say that vacuum can't have anything in it. You could say, well, I've got an empty bell jar. I've just sucked all the air out, so there's a vacuum in there. But it isn't, because there's a bell jar around it.
Yeah, the reason why I'm addressing this is I was listening to how. There's an echo.
Who's echoing? Ali's echoing.
Oh, 1 second, Dama. Hang on.
What I was trying to tell you last night, Ali, is, words, they don't have any intrinsic meaning. They have the meanings that we assign to them. They're just placeholders for things that we describe. So to kind of, say that, oh, a vacuum only means this, and just draw a hard line in the sand and say a vacuum can only be something with these characteristics. It's not the way that we use language.
Right. Yeah, words have usages, not meanings per se, right? So if everybody understands what the word usage is when they say vacuum, especially to a physicist or person who likes physics or knows about physics, we understand what that means. We understand vacuum to mean a situation where you have space that is devoid of matter or something at a low pressure, right? So the area between us and the moon is space, and that's a vacuum. There's nothing in there. There's a very low particle density, literally like 1 hydrogen atom every centimeter or so, cubic centimeter or so. That's considered a vacuum. Do you agree, Alan?
Right. Okay. Well, no, I can't, because that's not what I got taught. So we'll have
Well,
to
then you're
look at
taught
that.
wrong. You understood wrong.
Yeah, exactly. No, I got taught wrong.
No,
right?
no,
Because you
not
said,
necessarily.
let me finish. You said I'm using layman's terms. So that means there's a layman's terms definition and there's a physicist's definition. So that means there's two. I was taught the layman's definition at school. You can't blame me for that.
No, but
so
we
I'm
can correct you on it. So.
I should maybe go and sue my school for not teaching me properly.
Well,
then
yeah, you might want to take it up with your teachers. But now that you know the correct definitions, now that you've been educated on that.
Yes, thank you.
Good. All right, so let's move on from there. Okay, so go ahead, guys.
Well,
Okay.
A better idea is not long. You start at a 5,000-foot level where you're getting a wide view, and you never went beyond that 5,000-foot view down to the
Jared,
where you're down in the nitty. Start at that higher level.
yeah, you're
Jared,
breaking.
you're roboting.
You're roboting really bad right there, Jared. And I don't think Geis finished his train of thought there. Geis, where'd you want to go to?
No, I just wanted, the next, everybody probably knows where I'm going to go with this next one. Ali, you said you're a flat earther, right?
Yep.
Okay, are you in part of the proponent where the sun changes its size during the day?
No.
Okay. So in your model, how does the sun travel around the Earth?
Well, if I believe in the flat, it has to go round like that above the Earth, like that.
Okay, because
so
of the law of perspective.
Like that's, as I said, going. Sorry.
Okay, in the law of perspective, when something's farther away from you, it's smaller. As it gets closer, it gets larger, and then it goes away, it gets smaller. Correct?
Yeah, within our atmosphere, yeah.
It does it also in space, but anyways.
No, you're saying that.
Okay, but yeah, okay. I will take your answer of that. It works inside our atmosphere. So you're saying that the sun's angular size changes its size during the day inside our atmosphere. So you are a proponent that the sun does change its size.
I never said that.
I think he said no. He doesn't say the angular diameter changes.
Yeah, but he said inside our atmosphere the sun does change size. So I'm trying to get clarification. Okay, so
I says it doesn't change size. I agree with you.
Okay, so it doesn't change.
Maybe it's my accent. Sorry.
Okay, so I'm just trying to clarify before I ask anything else. Just give me a second here. So as you say, the sun. How high do you think the sun is above the Earth?
Well, that's up for debate, but I don't believe it's 93 million miles away. I believe it's a lot closer.
Okay, but once again, if something is going from far away to closer to far away, it changes size, right? Just like a car driving down the road. It's small when it's very far away. As it gets closer, it gets larger, and then
Yeah, but I'll repeat myself again. Yes, that happens here on Earth, right?
Okay,
Regarding space,
okay, I didn't say space. Remember I was talking when I asked you on the atmosphere, to you, the sun does change its size.
no, I
And you
don't.
said,
It doesn't. I says it doesn't when you're on the ground, and I'll have everybody back me up, hopefully, because what I said was, I said on the Earth when the sun is viewed from the Earth, yeah, I
yeah.
don't believe it changes size.
Okay,
It
but then
stays
you,
the same size.
okay, but it views, but then you go to, does it change size to your view?
No.
Okay, I'm confused right now because I'm not trying to trick you here. I'm just trying to
No,
make sure that because you said that the sun does change size inside our atmosphere. We're not talking about space, and that's a quote.
No, I never said that.
Did anybody else hear that?
You asked me. You asked me.
I think he
right,
said it
wait a
doesn't
minute. Let me.
change size.
Yeah, I think he's pretty consistent, guys. I think what he's saying is the sun does not change
Yeah.
size. We don't see it change size, but that it's not 93 million miles away. That it's some much closer distance. I think
Okay,
right. That's right.
Okay, okay,
Right.
I understand now.
Right.
But doesn't that violate the law of perspective? As things get come closer, they get bigger, and they go farther. When they go away, they get smaller.
Yeah, on Earth it would.
Okay.
That would. But the sun is not on the Earth, and it's not within our atmosphere, right?
Okay,
or
but
it's not within. Well, it is. It must be within our atmosphere because our atmosphere is space. It just goes. It degrades down. So there's no.
Okay.
As I say, there's no dome. Don't think I believe in a dome, by the way, because I don't.
Okay, I'm not talking about a dome. I'm talking about
No, I was just saying. Yeah.
Okay, so then there's a problem there, right? For you, because if the sun is going around the Earth and it's within our atmosphere,
Yep.
it should be going small to large, large to small.
Yeah, but I don't mean it's within our atmosphere, the scientific atmosphere before space. I still believe it's outside. You know, when our atmosphere disappears into that, what do you call it, a vacuum or a zero pressure system, that's when it changes.
Okay,
right? Because
but the sun is still getting, but the sun is still changing its distance to the observer on the ground, correct?
No, it's the same size, man. I've just
No,
said
I think
I don't understand.
What guys are saying is, look at if the sun at some point is moving away from you, it has to on a flat Earth model,
yeah, it does.
Yeah, it has. Okay, so if the sun is moving away from you, then the law of perspective would say that the sun's angular size, which is the distance of the disk that we see, would get smaller. Just as if it gets closer, it must get bigger. That's a law, right?
Yeah, on perspective on Earth, right?
But no, anywhere. You take
No.
Take your hand and move it close to your face. It gets bigger. Move it away, it gets smaller.
I'm standing on the Earth at the moment. I'm not in space. I'm not in a
I have always said you standing on the surface of the Earth. I never brought up space, so don't be bringing up space. I'm not talking about space.
Right.
I'm
so what I'm saying, let me finish. Right. Okay. Well, I'll explain myself. Right. I believe the sun goes round like that. Right. It's not within our atmosphere where there's matter, right, or whatever it is. When it gets lower and lower pressure density, right, at its lowest density, that's where the sun and the moon are, right? But it's still close. But it does not mean, remember, we're looking, and I can actually prove this. I've got a video on this. We're not seeing the sun at its actual size when we look at it. I've got a video of it. I'll show you a video. I'll share a screen of a video.
You don't have to. How did you determine it didn't change size?
Because I've got film of it.
Okay, and I have film of it not doing it. Now we have a problem.
Yeah,
I think he said the same thing that you said, guys.
Right, I've got film. Right, I've got film of the sun as its actual size when we look at it from the Earth. Right, wait a minute, let me finish, please. I'm very polite with you. Just mute yourself. Do what I do. Mute yourself. See, I mean, right? No, is this?
Get along with it.
I don't interrupt. See, there you go. Get on with it, right?
I'm seeing the disconnect here. I want to hear what Alan has to say because I think you guys are talking past each other.
Yeah, I think what Ali, if I understand you correctly, Ali,
this is a waste of fucking time, man.
Hang on. Yeah, no, Alan, no, we're fine. Hang on. I understand the disconnect, and I can explain the disconnect. But before I do, let Alan speak, Geist. Let him get his information out, because I know what's happening here. You guys are definitely talking past each other, and I'm going to explain it as soon as Alan's done, because I know what he's saying, I know what you're saying, and you're not saying the same thing. So Alan, go ahead and finish.
Right, thanks. Right, what I'm saying is when we look at the sun, right, at the moment from the Earth, right, through the atmosphere, that is not the actual size of the sun that we see, right? That's all I'm saying. And it doesn't get smaller, right? It doesn't get smaller as it goes far away when we look at it at the Earth, because it's getting magnified through the atmosphere.
Okay,
right? And that's what I'm saying.
Yeah, I understand that. The problem that we're running into is Geist is trying to explain to you that would break laws of physics from what you described.
No, perspective.
No, it would break the laws of physics. The reason being is it doesn't matter where you're standing. If an object is moving away from you, it's going to get smaller. Okay? So in your model where you said that the sun moves away from you, but you see the same size of it all the time, that's a violation of the law of perspective. Do you see that now?
Not if, but not if, like me, I believe that as the sun gets further and further away, right, because of the angle, right, it makes it the same size. So as it's going, if you're looking it up like that, it's that size. And as it goes away from you, because of the angle that you're looking at it,
right? But physics doesn't work that way.
Magnifies it. The atmosphere keeps. It magnifies it and keeps
epistemology making a lot of noise. Yeah, so the problem is, though, if you're moving away, even if the atmosphere was acting as a magnifier,
yep,
it would. The further it goes away, the magnification would be less. So
no,
even with listen, Alan, even with the magnification of the supposed magnification of the atmosphere, it's a standard magnification. If you're moving away from something, it has to get smaller. There is no way around that. Geist, is that what you're trying to say to him?
Yes.
Yes. Oh, you're muted, Alan.
We can't hear you, Alan. You're muted.
Alan, you have to unmute. There
Sorry,
you go.
I'm a noob. Right. Yeah. That's what I'm saying. So how come, right, as the moon gets further and further away from the Earth, it's always the same size?
Because it doesn't get further away from the Earth, and it will change up to 9%.
Oh, come on.
It'll change.
It goes from like 28 and some change arc minutes to 34 arc minutes on the supermoon.
I'm talking about 24-hour period. Over a month or so, yeah, it can change. As a matter of fact, we just had a supermoon not too long ago, which was a full moon, what is closest to us, was at apogee. So the moon does appear a little bit bigger, a little bit smaller, but throughout a 24-hour cycle, it's no notable difference. If you measure the moon early in the day and you move it, see it at night, it's going to have the same angular diameter, because it's not moving away from us at any appreciable rate. I mean, technically it is, and we found out it's about 4 centimeters annually, but you do that over a 24-hour period, what is that going to be? Nothing, hardly.
4 centimeters. That's very precise. Is there no error margin there, no?
Well, no, they know it's very precise because we have mirrors on there, and we can strike it with lasers and see exactly how far it's receding from us. Unless you don't believe we've been to the moon.
Actually, no. Well, I'm going to disagree with that. There's what are you using? Is it lasers you're using? Yeah.
Yes.
Right. Well, there's an error margin in lasers. I've worked with lasers. I worked with laser theodolites in my job, and we had over I think, if I can remember rightly, over a certain distance. Actually, they were accurate to 0.05.
Yes, and I said 4 centimeters, so we're not talking about thousand decimal places, right? So that's not very precise.
No, 4 centimeters.
It's not very precise.
No, I know.
Yeah, it's actually I think it's even less than that. I think it's about 2 centimeters, 2 point something centimeters a year, and they have got it very precise. Matter of fact, I'm trying to find it right now because I'm trying where I found this. And I think I just did. Here we go. The average recession rate of the moon is between then and now has been 2.17 plus or minus 31 centimeters a year. That's pretty precise. And they can measure that again with lasers, but that's within the tolerance.
Sorry, repeat that again. I missed
2.17 plus or minus 0.31 centimeters annually.
Right.
That's pretty. I mean, that's pretty good, and it's well within the precision of accuracy for a laser. We're not talking to the 10,000th decimal place or something. We're only talking to the thousands. I could do that with a micrometer. I can get to that.
You realize it's not the accuracy of the laser in that case; it's the accuracy of the clock. It's
Well,
timing the return signals.
The time it takes to go back and the Doppler effect and all that. Is that right? Yeah.
It's calculated it's calculated.
I don't want
we
us
can
to get off
calculate it
track
No,
Go ahead.
from the original argument, which was, I guess what Ali is saying is that the atmosphere will lens the sun perfectly so that the magnification increases as it moves away, so that it keeps the same size. In other words, it's like having like a zoom lens on it, and the zoom just keeps increasing as it moves further away, so that somehow it precisely keeps the same angular size essentially through the atmosphere. Is that kind of your position, Ali?
That's very well said. Thank you.
Okay, but here we run into another problem, Ali, which is in all the flat Earth models, the sun is moving around in a circle over the flat Earth, right? Which means that from the perspective, let's say on the equinox where the sun is moving in a circle over the equator, what we actually see on any point on the equator is that the sun will rise due east. It'll go in a straight line, straight up overhead at your zenith, and then it'll go and set west in a straight west in a perfectly straight line. But the problem is that on the flat Earth model, the sun is actually going to come in from the northeast. It'll go overhead, and then it will set in the northwest, because that's the way that its motion is going. So not only do you have to account for the size, you have to account for why the azimuth doesn't change, right? The azimuth goes from due east to due west once it's zenith on the equator. That's what we actually see. And then for people in the northern hemisphere, the further north they go, the sun it rises due east, but then it moves over through the south sky. And the further north you go, the further south it goes. And then vice versa on the other side of the equator in the southern hemisphere, where it'll rise due east, but then it'll be north and east. So I don't see how that would work with the sun that's traveling in a circle around a flat plane. We should see an azimuth change anywhere on Earth, but we don't.
Right. Okay. All that means is you can't explain that, so therefore it doesn't happen. It's impossible for it to happen, right? I can ask you a question then, right? Because you're using Earth-based physics for that,
Earth-based. Okay, wait a minute.
Yeah, like what's his
explain-
name? Newton, for example, right? His laws of gravity. They flung that out the window when Einstein came along and changed his. Well, he said, only works down here, right?
Newtonian dynamics
We have
actually
a physicist in the room, and I took a little bit of physics.
Yeah, but
as
it
well,
only
because my
works here.
background's a nuclear reactor.
That's fine. That's fine.
Yeah, I can tell you right now. Yeah, I can tell you right now, they didn't fling Newtonian physics out the window. Matter of fact, we still use Newtonian physics today, quite often.
And what, in space?
Yes, in space.
Okay,
Absolutely.
give me an example. Give me an example.
Okay, hold on a second here. I've been sitting here quiet in the corner because Ali wanted to talk and finish his sentence, and I'm waiting for the point where he's done with answering my first question so I can continue on. Now we're going off to a whole separate subject.
Go ahead. We can come back to Newtonian physics because I know you're on a time schedule. Go ahead, guys.
Okay, so we determined that your sun doesn't change. Okay, got it. Ali, do you know what a sextant is?
Yeah.
Okay.
I think, yeah.
Okay. How does a sextant work on a flat Earth?
How do you mean? How does a sextant work?
How does a sextant work on a flat Earth?
Well, doesn't a sextant just measure angles from the horizon? Doesn't it look over at the horizon and then you adjust for the angular?
Yeah, you have a star or something like that, like the sun, and then
yeah, of course. So, but I don't understand.
But then you can just bring it down to the horizon, and that tells you the angle of the star.
Well, there you go. That's how it works. So how does that prove it's a ball?
Okay, hold on a second. Can I finish? First off, a sextant does more than it does measure angles, but measure angles very precisely, and it also for example, you can measure the angle of the sun and stuff like that, and stars at night in different parts of the Earth to figure out your location, especially over water. That's the reason why it was developed over the theodolite, because the theodolite didn't measure angles, say like of the sun and stuff like that. Theodolites were mostly used for measuring angles of the stars. but a sextant requires 2 hemispheres to work. Can you show me 2 hemispheres on a flat disk?
Can you hear me? Yeah. Why does a sextant need 2 spheres to work? I don't understand.
No, I didn't say spheres. I said 2 hemispheres.
Oh, hemispheres. Sorry, 2 half spheres. Okay. And how? Why?
Okay, because a sextant works on the northern hemisphere, where the longitude lines are the latitude lines converge to a central point called, as we would call the North Pole. In the southern hemisphere, the sextant requires the latitude lines to converge at a southern pole. If the lines continue to spread out, like on a flat Earth, say like a bicycle wheel, as they spread out, the distance gets worse and worse. On a sextant, when you go through the Nautical Almanac, and the farther you go south, you start calculating that the latitude lines will now start to converge, not spread out.
Oh, okay. Yeah, well, that still didn't explain why you need 2 hemispheres.
I just told you why, because the latitude lines.
So do you need 2 different sextants then? Sextants.
What do you mean 2 different sextants?
One. So if I go up here north, right, I can do my measurements. For example, the angular size of the moon, for example, right?
Nope. It doesn't measure angular. Hold on, stop. Before I want to correct you, it doesn't measure angular size of the moon. It measures the angles of the horizon. From
the horizon.
Yeah, from yeah. I just want to clarify. Continue.
Yeah. No. Yep, that's right. So then, I don't understand what difference it would make if
the sextant works. The sextant works exactly the same in the northern hemisphere as it works in the southern hemisphere. The farther you get to the poles, the latitude lines start to converge. The sextant calculations take account for that. So as you go farther south, the lines will start to converge. So if you have one ship on one latitude line and a ship on another latitude line, on a flat Earth, they would spread out. But in reality, they actually start to converge.
Yeah, I think Alan, what he's saying is, we know the sextant works. Okay, now on a flat Earth, what I think he's saying is, if you travel toward like the edge of the disk, it's going to be more spread out. You're not going to get the correct angle of where that star or sun is going to be in the sky with your sextant. It's not going to be accurate. Is that what you're saying, Geist?
Not only that, but also the latitude lines need to converge at a central point in the South Pole, same as they converge at a central point in the North Pole.
So where would be the convergence on a flat Earth?
No, wait a minute. Can I just address that, what you just said there?
Yeah.
So I don't understand what difference, does the sextant actually measure latitude lines?
Yes.
Are you sure?
Yes, I've been using one since I was 10. It measure. Okay, I will tell you how you do it. Because what you do is you measure the angles with a sextant, and then you look in a book called the Nautical Almanac. It's put out every year. You can look it up online. There's tables in there in reference to the angles of the sun, the star, different stars. You don't measure angles of every star. There's certain stars you got to look for because they're usually the brightest, and they're let's go from there. And you also use a chronograph. A highly accurate timepiece. The more accurate, the better. If you're off by 4 seconds, you're off by a mile. The problem is, though, is that a sextant, when you do your angles and you do your calculations, you find your place on the Earth. And as you're in the southern hemisphere, just as in the northern hemisphere, the farther south you go in latitude, the lines will start to converge. As you move from one latitude line to another latitude line, they're not spread out. They actually get closer together. So the time it takes to go from one latitude line to the next latitude line at a certain speed will be at this rate. Now, as you're going farther south and you're crossing across the latitude lines, the lines will start to get smaller and smaller between the distances between the two, because they're now beginning to converge at the central pole or the South Pole. And it doesn't need a compass either, because nautical navigation, a compass is not accurate. A compass is not accurate enough because you're not dealing with magnetic; you're dealing with pole.
Right.
You're dealing with the geographic, not the magnetic.
Yes, a sextant requires 2 hemispheres to work.
Yeah, you really are working with the lines of latitude with a sextant.
Yes, as the farther you go farther south, as you cross from one latitude line to the other, past the equator, the lines will start to get closer and closer together as you travel from one to the other, to the point they will converge at a central point. If on a flat Earth, that should not happen because the spokes of the wheel continue to spread out. So the latitude lines should be increasing in distance, but that is not what we see. We see a decreasing in distance as you go farther south, exactly the same way they decrease in distance as you go from equator to the North Pole. It works exactly the same on the North Pole. Sorry.
Oh, right. Okay. So can we agree that the latitude and longitude lines are imaginary lines?
Yeah.
Yes, of course they are.
Right. Okay.
Well,
okay.
in that
Nobody goes draws them on the Earth. Yeah, they're
Of course they are. There was no need for that. That's hurt my feelings. Jeez, man, there was no need for that.
Well, you asked the question, so we answered.
No need for that. Yeah, but you said, of course. You didn't have to say that.
Okay. Yes. Moving on. They're man-made constructs.
Right. Okay. Right. Right. That's fine. So a sextant doesn't actually. So a sextant, you're telling me, is measuring imaginary lines on our ball.
No.
Right. So a sextant
it measures
imaginary lines. Then.
No, it measures angles to reality, stars, and whatnot, and then places you. Hold on a second. It measures angles to certain objects in the sky at certain times of the day.
And that gives you your latitude.
When you place the and when you place that position on the Earth, we fall within the grids of longitude and latitude. That's how we navigate from point A to point B.
In other words, oh, sorry. Go ahead.
That is, for example, that's the reason why, sextants are best used. Well, they're almost always used on the water versus the land, because land has hills and stuff like that. So you need a horizon that's flat, so you can do your angles right. If you're on land, you have to deal with surface features such as mountains and hills and valleys and whatnot. But you need to have a relatively flat horizon out in front of you. That way, when you do your angles, the sun or whatever star is so many degrees, so many arc minutes above the horizon, and then you start doing your calculations, it places you at this particular point on the Earth. And as you're traveling,
I've got to disagree there. All you need to know is your height above sea level for a sextant to work. It doesn't matter if you've got
hold on a second.
You're looking at stars to measure.
Hold on a second. I will answer that question. That is part of the calculations. In the Nautical Almanac, there is actually a part in there that deals with height above the sea and refraction. Refraction is actually calculated inside the tables for 10 millibars. Right. Refraction has different values depending on how many millibars. Millibars is how you measure the atmospheric pressure above the water. So when you hear like a news report talking about so many millibars, well, they're not really doing news reports, but when you're dealing with marine radios, you hear about there's a storm coming in, there's going to be so many millibars. And the reason why they say so many millibars is if you're using a sextant or anything for navigation, that has to be taken into account. So refraction is taken into account, and it's also part of the calculations.
So you're saying that millibars measures perspective as well, yeah?
No, millibars measure atmospheric pressure at the surface of the water. So many millibars changes how the refraction level is. The standard.
Also, the pressure of the atmosphere decides how the light refracts in. Yeah, is that what you're saying? And if you're at a certain, the
denser the atmosphere, the denser the lens.
Right. Okay. Right. That's right. So a sextant measures. Wait a minute. A sextant measures millibars as well. Then, yeah.
No.
Well, so how can you take into account the millibars?
Because you have sensors that do that. Also, hold on, and also before you go there, the standard in the Nautical Almanac is 10 millibars.
So that's a constant.
It doesn't have to be a constant. It's a constant within the table. Because sextants have a margin of error. They are not precise like GPS. I have traveled from Kodak, Alaska.
GPS is not precise.
Hold on. Yes, it is. We're not going to go there right now. We're talking about sextants. So sextant is not precise. Like I said, if you're off by 4 seconds in your calculations, you will be off by 1 mile. If you're traveling over time and you increase that 4 seconds to 8 seconds to 16 seconds, and you keep adding to it, the miles get bigger and bigger and bigger. So you're eventually going to miss your target on the other side of the Earth. That's the reason why when you're using Sextant, you need a chronograph. So you use ultra precision on your navigation or your timekeeping. But a Sextant
That's on the sea. On the sea.
Yes, a Sextant is used on the ocean. But once again, a Sextant requires 2 hemispheres to work, because as you travel south, the latitude lines must converge at a central point. The distance, the time it takes for the ship to go from one latitude line to the other as the ship goes farther south decreases, it does not increase. Yet the ship can still find its place as it's traveling across. If the lines change, if the distance changed, then its course would be off. Yeah, the ship is not. It works exactly like I'm gonna repeat myself. It works exactly the same in the northern hemisphere as it does in the southern hemisphere.
Right. So what you have to do is take a measurement with your sextant, right?
Yeah.
And then look at the longitude lines on the imaginary longitude lines on the ball. Yeah.
Nope.
Well, how do you find out your longitude then?
Using the nautical, by using the nautical almanac.
Exactly. So your which is
what?
Well,
it's a 251 page booklet that's put out every year.
Oh yeah. I'm well aware of what it is, because they use it for the tides as well. You know.
Nope. There's anything about tides.
Well, actually, it does.
It's not a tide book.
He heard the word almanac and he thinks it means the farmer's almanac. It's not. It's another specific.
No, not the farmers. No, not the farmers. The what do you call it? The nautical almanac.
Doesn't have.
It has to. If with tides,
it doesn't. It doesn't. You know why? You know why it doesn't?
Right.
Because the ship is on the tide. It doesn't matter.
But the tide's moving, so that will have.
The tide's moving in reference to the land, but it's not measuring the land. It's measuring the horizon.
Yeah, but if the tide's moving, that means it'll affect.
It doesn't.
The ship movement.
In the nautical, to the audience, in the nautical almanac, there is no tide book. All it is angle calculations when you're dealing with celestial object in the sky. It does with moons and the stars. So at January 1st, at this time of day, at this latitude, you will see the sun at this angle. That's what it does.
It has nothing to do with the tides. There's no tides in the book.
Oh, is there no tide? Well, I apologise for believing that. Yeah, well, that's another misconception, but it doesn't take away the fact that I don't understand why you're saying that the sextant in the southern hemisphere is calibrated to the imaginary longitude and latitude.
No, it's not calibrated. It's calibrated so if it gets bent and stuff like that, that's what I mean by calibration. But you could take a sextant and use it in the northern hemisphere, cross over the equator, and use it exactly the same way as you're in the southern hemisphere. But instead of looking for Polaris and constellations in the northern hemisphere, you're now taking star readings off Sigma Octantis and other positions in the south.
Yeah, but I'm obviously I'm not.
Yeah, I think you're a little confused here, Alan. I think you're a little confused here. But
well, of course I'm, because let me finish. I'm just a bit confused. What happens if? Have they always used the North Star to navigate?
When you're the North
Star to navigate.
Okay, I will answer that question. If it is visible, yes. If it's not visible, there are other stars that they can use. And those stars are also taken into account inside the Nautical Almanac. So if you can't see Polaris, you can go, say, after, I'm looking at my star chart right now, I can go after Ursa Minor. I can go after the stars in stars inside Ursa Minor. What's Athlon, Duvet, Akid, and there's all kinds of separate other ones. I mean, right now I'm just looking at my computer.
Right. Okay. And then as the time changes, because you said there's a chronograph, like a watch on board, yeah. That
Yeah, when
measures
you're doing your star sighting, if you say like I'm going out to Polaris, okay, I orientate on Polaris, I find Polaris, then I find the local time that I'm at. That's why you need a chronograph, and then you do a shot. You record the time, you record it in seconds before hours. You measure the angle, then you look in your almanac. You take in account that the star that you're looking at should be at this, or Polaris will be at this angle to the horizon. So once you determine that, now you start dealing with dip angles. You start dealing with refraction, and you start dealing with. Let me look on the rest of the chart here. What's to do with?
Hey guys, I think we're getting kind of bogged down in the technicalities. I think we could sum it up by just saying, look, sextants work on a sphere with two hemispheres. We know this that it is. He's actually supposed to be demonstrating to us the flat Earth position. He's supposed to be showing us why flat Earth works. So he needs to show how a sextant would work on a flat Earth. That's what I kind of like to hear. But if he doesn't know much about flat Earth, much about sextants, I don't know how you would even begin to do that.
Yeah, well, let me explain. This is the thing we're getting bogged down in. I don't see what difference is. If you've told me it uses different stars, yeah.
Yeah.
On the thing, who says that on a flat Earth you can see the North Star all the time?
Because if you put your, I will answer that.
Oh, well, wait a minute. No, well, it was kind of rhetorical. I was talking to myself now. But obviously you can't. So there's some reason why you can't. And I know you're going to say it's a ball, but there's obviously another reason.
Well, it's the ball.
Well, yeah, it's the ball. But okay,
first
of all, Ali, do you know what circumpolar means?
Circumpolar, that'll mean to go round the.
Yeah, just basically a star that doesn't go below the horizon. Yeah. Okay. So Polaris, like for example, I know exactly where Polaris is from my house. I could walk outside on any given clear night, and I could just put my finger and point right to Polaris. I know exactly where it is. It doesn't change. Do you agree with that?
Oh, absolutely.
Okay.
And it hasn't for thousands.
Can I address this star thing real fast?
To that, yeah.
I need to address the star thing. Okay, in the Nautical Almanac, as the farther you go down south, as the farther you go south, the Nautical Almanac, the part where it has for Polaris is lined out.
Because you can't see it from the South Pole or South Hemisphere. I mean.
Yeah.
You're muted again, Alan.
Sorry. So, but that doesn't necessarily mean you don't just suddenly jump from because we can't see it, therefore we must live in a ball.
Well, actually, it kind of does.
Yes,
actually.
you can.
That's actually exactly what it means.
No, you can. But
let me show you why, Alan.
I couldn't say that. I couldn't. Right, wait a minute. I couldn't come. Well, wait a minute. I couldn't come to that assumption.
It's not an assumption. It's a conclusion. There's a difference.
No, it's not. No,
well, let me show you why it's a conclusion. As I said, I was saying that I could point to that Polaris, right? Now, if I got in my car at night and I started driving due south, right, and I start going into Mexico, and I keep on going, right, assuming that I can keep going. I can watch literally Polaris get closer and closer to the horizon because it gets closer to zero latitude. As soon as I'm in the southern hemisphere, I can no longer see Polaris. I can turn around and I can go back north. I'll see the Polaris be higher than the zero. And if I drive all the way to North Pole, guess where Polaris would be? Exactly 90 degrees above me. That demonstrates conclusively that we're not a flat Earth. There's no explanation.
And not only that, in the Nautical Almanac, at certain times of the day, Polaris will be at certain times of the night, Polaris will be a certain degrees over the horizon. It's known how its angle is going to be already.
Yep, and it doesn't change throughout the day.
But that doesn't necessarily lead to the fact that we live in a ball.
Okay,
it excludes once again,
flat. It is a conclusion, but once again, you're forgetting that. Once again. You're forgetting that a sextant requires two hemispheres to work. It needs the latitude lines to converge at a central point in the south to work.
Yeah, even if we acknowledged, which I don't believe is true because it isn't, that it doesn't demonstrate around Earth, it excludes. It means it takes away the possibility of a flat Earth. Flat Earth is eliminated by that observation. Completely eliminated.
Well, why? I don't understand. So what happened to the laws of perspective and stuff like that?
It has nothing to do with the law of perspective. It's the fact that you're going below a position from which the object is being visible because it's behind the object you're standing on. Polaris literally would be behind the Earth in an angle, very small angle, but enough where you cannot see it because it's below the horizon. That only is possible if there's a curvature there. That cannot happen on a flat Earth. It's impossible. And that's why no flat earther has ever been able to just show a model, because it's not possible.
The important thing to remember is the movement of these objects, they perfectly correspond to movement on a sphere, and they don't correspond to any other object. That's the reason why you come to that conclusion.
Yeah, but I'm just thinking. Well, do you know? For me, it doesn't really conclude anything for me, that because you're getting further away from an object, right? Right. So I don't understand how. I mean, there could be all sorts of other.
Okay, we're going off topic here. We're talking about how a sextant works on a flat Earth. A sextant, once again, requires that the latitude lines converge at two poles, just like it does in the northern hemisphere.
No, it doesn't. It doesn't.
It does.
It's not measuring latitude lines. It's measuring angles of stars.
Yes.
Not imaginary lines. It's stars.
It doesn't measure latitude lines, but it's putting you on the surface of the Earth on a latitude line, a surface of the Earth, and as you travel from one point to the other, your angles will change.
Yeah,
you measure the angle change. As the angle changes, it places you in a different place on the Earth. And when
but doesn't.
Go ahead.
Didn't we just agree that the further away you got from an object, it gets it gets smaller on Earth?
Yes. Okay. Right. And your point is what?
So why can't it go lower?
What go lower?
Well, what you're talking about, you're saying about the north, is you're getting further away, right? That if you were standing on for example, the North Pole, it would be right above you, right? Is that right?
Yeah.
It'd be perpendicular to the Earth. So as you got further away, wouldn't the angle get lower?
It does, but the sun doesn't. But the star doesn't get smaller.
Well, but the angle gets low as you go further away.
Yes, as you farther you go away from as farther you go south, and you look at Polaris, the angle from the altitude of Polaris over the horizon will decrease, and to the point that it disappears over the horizon. At that point, you orientate south, and you take all your measurements from southern stars.
Right, there you go.
Right.
That's it. The orientation differs, and you take it from the southern stars because you're no longer taking it from the northern stars.
Yeah,
that's why you use the two hemispheres.
Because you can't see them, right?
Yeah, because you can't see the northern stars from the southern hemisphere.
Right, but see that, I mean, that there doesn't prove that it's a ball.
Well, okay, but like
I don't see how it does.
Well, first of all, it does demonstrate you need two hemispheres. Now, it could be a regular spheroid, it could be maybe a cube, I don't know. But the point being, by the way, we have 100 people watching on a Wednesday morning, so this is kind of odd for a flat Earth discussion to have 100 people watching this early in the morning. But hey, thanks a lot, people. But what it does do, Alan, is you haven't acknowledged the fact that it eliminates your flat Earth model. Now, once you eliminate the flat Earth model, then we can give you other reasons why the Earth is round or spheroid, right? So
but how does it? See, I'm stuck. We're stuck in a place here, right? You're saying it eliminates. I'm saying I don't see how. You haven't given me a good enough explanation.
Then all you have to do is explain why I'm driving.
Listen.
Well, hey, I'm driving to Mexico. I'm driving to Mexico. I can no longer see Polaris after I enter the southern hemisphere. Okay, explain how that happens on a flat Earth. Show me a model by which anytime you have a flat Earth where I can reach a certain position on that Earth and not see Polaris.
All right, but doesn't the horizon get higher?
No, it actually drops with altitude. It drops with altitude.
Your horizon will get higher, no?
Drop as you increase altitude.
No, I'm not saying increase altitude. We're driving down to Mexico. Say we're driving down.
Yes.
Right, and we're looking back. Does the horizon actually rise up?
Well, first off, you're on the land. So let's put it a different way. If you're on a boat and you're going from Alaska down to Easter Island, as you're traveling across the ocean, the horizon line in reference to the bow of the ship or the stern will not change.
Yeah, I mean,
unless the boat starts sinking.
Yeah, he guides knows ships very well. I was in the Navy for 4 years. We've all gone to the southern hemisphere. So
yeah, but but you going to the southern hemisphere doesn't prove it's a ball.
Okay. If you really want to go there, I've been to Antarctica and I've been to the South Pole.
Yep. Right. So no, you've been to
Yep,
a place
yep.
called the South Pole.
Okay, now you're going into how. Then I will ask you, how do they convince me I didn't go there?
No, I've said no. Wait a minute. Oh, so did you have a compass and it started
I
spinning
had
around?
I have been to the South Pole and brought up my personal sextant.
Yeah. No, right.
And
Okay,
I also
that's
know,
fine.
and I also know how to measure shadows.
Yeah, I know, but
You could take a picture of a shadow. You could take a stick 1 foot tall and stick it in the ground, and I can tell exactly where you are on the surface of the earth just by that picture.
Not sticks, man. Don't start with sticks.
What did I just tell you? If you stick a stick in the ground 1 foot tall and you take a picture of it, I can find out where you're at in any world just by the shadow angle.
Well, again, I still like him to.
Wait a minute. Hey, whoa. I'm going to stop you there.
Want a bit?
So you're telling me you would have to know the time?
Nope. Because I know sun angles at any particular time of the day just by using the nautical almanac.
Yeah, but you're saying, I told you would need to use time to measure that, and you said no.
Nope, I don't
use time. So I could. Right, so I could basically not tell you where I was, stick a stick in the ground, take a photograph of it, looking at the shadow, and you could tell me exactly.
Yeah, because I'm going to measure the length.
Guys,
I'm going to measure.
Wait a minute. Okay, guys, anybody in chat want to do that, right? Take a photograph.
No, I see what he's saying. I see what he's saying because the angle is going to be the same. The only thing that's going to change the other day is the length of the angle or the length of the stick, right, guys?
Yep.
Yeah.
No, the time.
No.
You're telling me if the sun goes over there, it's going to be the same shadow.
I see exactly what he's saying. The length of the eye is going to change, but you can actually take an angle measurement that's going to be consistent.
But you'd have to know the time.
No,
basically, I'm using the stick and as a picture. Basically, hold on, I'm telling you how I can do it because I'm using the stick as a sextant on the ground. That you basically put a sextant on the ground for me to look at. I can measure the angle just like a sextant does.
Right. So
by looking at it, I can tell what time. I don't need a time of day because I can measure the angle.
Well,
if it's 1 foot long and the shadow is a certain length, I can tell what time of day it is with it.
Yeah, you're taking. You have two things.
I don't think so.
Well, you're wrong. You can just.
Anyways,
you have different things that you're measuring here. One, you know the length of the shadow, and you know the angle. You can figure that out. What Geis is saying. You have two pieces of information right there.
Oh, you need two pieces of information. He just says put a stick in the ground.
Right. Well, yeah, that gives you two pieces of information. It gives you the length of the shadow, and it gives you the angle of the shadow with reference to the stick itself. Right, Geist?
Yes, to the angle to the sun.
But all you could do is tell the time. Then that's all you could do with that is tell the time.
Because I can tell how the shadow angle of a stick. Like I said, it has to be 1 foot tall.
Right.
Just because you can't do it doesn't mean other people can't do it. Just because you don't understand it doesn't mean other people can understand it.
Yeah, I have to kind of agree with that, Alan. I mean, we're not, first of all, we're not. I thought you were supposed to be explaining to us the flat Earth, not us explaining to you physics and stuff like that, which we're happy to do.
Well, that's not physics. Sticking a stick in the ground.
Well, it is science, though. It's trigonometry.
It's geometry.
It's geometry, trigonometry. It's name your poison. But the point being is, you as a flat earther, need to show us. Right, the purpose.
I don't need to show you nothing. I don't need to show you anything.
Alan, you said this is the purpose of the hangout. You said you would teach us the flat Earth model, and I gave you a perfect example.
I never did. I haven't got a model, so that'd be I never did go. I'll go back into the chat and you show me where I said that.
Let me take the word back to word model. But you were going to explain to us flat Earth, right? So, given my example that I went to the South Hemisphere and I don't see Polaris, how is that going to work on a flat Earth? Do you have a way for that to work?
Now, we need to get something straight here. I never said I was going to prove the flat Earth. You asked me if I was a flat earther. I said yes. You said, would you like to come on and discuss it? And
I did, first of all. It wasn't me. Yeah, it was them. But it was them. But pure.
Hang on. Someone's got an echo.
So hang on. So I just want to get on record. You can't explain on a flat Earth how I would not be able to see Polaris in the Southern Hemisphere. You can't explain that? As a flat earther.
Right, say that again.
As a flat earther, you cannot explain my observation of why, if I left my house today at night, look at Polaris, go south, watch it go to the horizon, and then go below it. You cannot explain that on a flat Earth.
Yes, I can.
Oh, there you go. That's what we're looking for. Go for it.
Right, perspective.
Well, wait. And even then, this did start by me saying that I was looking for a teacher of flat Earth who could answer these questions.
Yeah, and he's going to try to answer it.
Yourself.
Yeah,
Oh, did you? Let me
how
check that. Sorry, I'll apologize if that's right. I'll just have a look.
Yeah, it was him. So
I'll just
explain to us
have a
how.
look at
Yeah, explain to us how perspective does this. I mean, you can't just throw out a word and that's an answer. How does perspective work on a flat Earth to match the observations I gave you?
Wait a minute, I'm just checking here.
Checking what?
Well, whether I did say that I would come on and teach about flat Earth.
I believe you did.
Okay.
I'm just looking. I'm going back to the thing. But anyway, never mind that. Right.
Before I go hang up here, then he has a problem with this talking about how the if he's talking about that the perspective and the star disappears in the back because of its distance, and then it basically fades away. Then he has a problem. Then he has a problem with his sun model, because how come the atmosphere is not keeping the star at magnification just like it does the sun?
Well, that's one for someone that knows a little bit better about. You have two contradictions. It can't be one. It has to be one or the other or none. Well, I just said this. I never said the sun changed size, right? And
no, you said it doesn't change. You said it doesn't change size because the atmosphere. Well, the sun actually physically changes size, but the way you see it on the Earth, the atmosphere acts as magnification to keep the sun exactly the same size. How we're viewing it, but now you're going to argue that stars will disappear as they go farther away. But that but when the atmosphere also,
I never said they disappear, but lower.
But wouldn't the stars be the same? Keep the same magnification? So you still should be able to see Polaris on a flat Earth from the south, because the atmosphere should be magnifying the star correctly, just like it does with the sun, right?
Yeah, right. But Polaris doesn't move through the sky, right? It's always in the same place.
Okay, hold on. Let me stop right there. We don't need to go with Polaris. There are stars around Polaris that disappear also, and they move.
Yes, there are stars that are circumpolar. This is what I said before. That they're near Polaris. That if you go too far south, you're not going to see them anymore. But again, I'm still waiting for your explanation of how this happens on a flat Earth. You can't just throw out perspective. That's not an answer. How does perspective allow you to not see a star in the southern hemisphere?
Because you get full. But there is no southern hemisphere.
Yes, there is.
It's flat.
Okay. When I go to Mexico and I reach what we consider to be zero latitude, we're going to call that the southern hemisphere. It's killing me. So, God damn it. You're killing me here. So whatever you want to call it is fine, but I'm now in the southern hemisphere, or the south of the zero latitude. Now, if I'm south of zero latitude, explain to me on a flat Earth why I'm not seeing Polaris. And this same perspective is not an answer.
So I keep forgetting. I keep doing that so I don't interrupt. I've got an awful habit of interrupting people. That's why I keep muting. You get further away from it, so it gets lower on the horizon.
How is moving further away something going to lower it on the horizon?
Well, it does it with ships, right?
No, it doesn't.
When a ship goes across flat water, the flat water, because it's flat, right?
It's not flat.
It disappears.
Can I get in on this?
Go nuts, man.
I'm at work right now, so damn it, Steve. Why do you get all these?
It wasn't my idea. Don't blame me. Blame them.
Oh, this is the attack now, right? Cool. I was waiting for this.
It's Cortez's fault.
Steve, just so
show your colors.
My favorite color is red, so at least now you know that. So anyway, the law of perspective states that alpha equals 2 times the arctan of g over 2r. That means that as an object gets further away from you, it's going to shrink in totality. Please explain to me, good sir, how that equation gives a bias, a bomb half of the image at an arbitrary distance, while keeping the angular size of the object the same as we see with Polaris.
Well, let me just tell you, my little friend, like you always do, you bring in equations and stuff like that and I don't
damn you and your math.
No, not damn you and your math. You're fake. It's not even proper maths, right? Use guys.
Bullshit. It fucking works. Is I can use a sextant in my calculations to plot myself across the surface of the Earth with precision using math. I can get from point A to point B, so math does work in practicality.
Yeah, that math. Yeah, not all math
Yes.
works.
It's the same kind.
It's the same
No, it's
kind of math.
not. No, it's
Ali,
not. Why
Ali,
do they
this
keep
is
changing?
trigonometry.
Right,
This is
why?
trigonometry, okay? This is nothing that is completely complicated. You can literally draw a picture of this shit and do the math yourself, and what you see on the paper will match your equations. Therefore, math actually comports with reality, and these are the same exact equations I'm using. So please tell me, good sir, how does the law of perspective, which is a mathematical equation, I don't think you actually knew that. The law of perspective is a mathematical equation, so according to the mathematical equation, how does it give a bias to bomb half the image when the equation itself says it will shrink in totality?
But, okay, right, and so what happened to the sun? Does that not follow the rules of mathematics? Because that gets
It doesn't go away in distance, so it doesn't change size. No problem.
What do you mean? But the Earth doesn't. It's not in what do you call it? It's not in a perfect concentric.
Yes, but the thing is, the sun is so large that we are so far away from it that the size that it does change is so minuscule you can't see it unless you actually measure it.
Alan, the measure from the sun when it comes up over the horizon to when it sets. Let's say it's 12 hours or whatever it is. That's not a noticeable amount of difference from when the sun's going around the Earth to make it a measurable amount of change. So there is no change that we can visually measure of the angular diameter of the sun. It is not notable. Do you understand that?
Right, it's not notable, but see, this is the thing. I mean, you choose when your maths.
Ali, first off, it is noticeable, but you need a high precision. You do need an instrument of high precision to measure it.
Hang on, let's correct this. It's measurable, but not really noticeable. Right, we're not going to notice it. We can't. If you just take, I know you guys love the P900. If Reg took his P900, which he has, and took pictures every half hour, it's not noticeable. Now, if you use very high precision instruments, then you're going to be able to detect some change, right?
Okay, so the sun does change. So now we're agreeing. Wait a minute.
Hang on, Alan. Hang on.
Oh, okay.
Even then, the sun, you're only going to really notice the change in angular size throughout the course of a year, not the course of a single day.
Well, that's what I'm saying. You got to remember this. The sun is also dynamic, Alan. The sun expands and contracts. Do you know what holds up this? Listen, Alan. Hang on. Do you know what holds up the sun? Do you know why the sun is not collapsing on itself or exploding? Do you know what the relationship is going on in the sun?
Right, being on lunch break.
According to whom?
To science, physics.
Right. Okay, explain that to me, please.
Balancing after gravity as opposed to gamma pressure, which is gamma rays being released from the core of the star. So it's a pressure balance. Okay, so it will fluctuate throughout the day. Every second the sun's fluctuating. It's a ball of plasma. Okay, so it's not like it's a solid object. So when you talk about the angular diameter, just the fact it's a plasma gas has some variation in it.
I thought it was. What was it? I'm a bit confused here. So you're saying it. So now it does change in size. Yeah, I know. So now it does. First of all, you said it doesn't change in size. Now it changes in size.
Not noticeably, we said. There's no notable difference.
Okay, this is going to solve all the confusion right here. Okay, here's basically what we would see on that map that flat earthers like to conveniently ignore. On a round Earth, the angular size is going to change, but you're going to need very precise instrumentation to actually notice it. On a flat Earth, what I should expect to see is the sun rise at one angular size, grow to 4 times bigger at noon, and then shrink again to the size it was when it rose. We do not see that. I took my P900 with a solar filter to get rid of the glare because flat Earth just fucked that up as well. And I was able to check the angular size throughout the day. And I could tell, or I couldn't tell it changing whatsoever from picture to picture. Superimpose any 2 pictures from any 2 times on top of each other, and guess what? They are the exact same size. Not at all what we would expect to see on a flat Earth.
Yeah.
So you just wasted $1,000 on a camera that's worth shit.
Well, Ali, according to you, the sun doesn't change size because of the atmosphere, but the atmosphere should also affect the stars and keep them in magnification also.
He demonstrated. Hang on, Alan. He demonstrated what is consistent.
Hanging on me.
He demonstrated what is consistent with a round Earth. You just said something that was strange. You said, "Oh, he had a useless thing." No, what he is not useless, because what he demonstrated is observations what we would expect with a round Earth. And I don't know why you find that's funny, because that's kind of simplistic.
And I also want to make you aware that the people that told me to buy the P900 were flat earthers, and now that the P900 shits on their parade, they're saying it's shit. Oh, the fucking irony.
Yeah, they told him buy the P900. You'll see a change.
But they were just taking the piss out of him, man. They don't realise everybody takes the piss out of Red because he gets so triggered. They love just going on and talking to him.
Okay, but the point
he gets
being,
triggered all the time. You know what I mean?
Alan, okay, but the point being, Alan.
And now they're regretting it, because now I use that camera to film rocket launches, which also debunk a flat Earth. But
yeah,
continue.
so the point
No,
being,
rocket.
Alan,
All right, wait a minute. Stop now, Red. How does rocket launches debunk the flat Earth?
Well, that's a whole different topic. Hang on. We're not.
Oh,
Can we get back?
Yeah.
Can we get back?
We still need to get back to the Newtonian mechanics. So we're not going to get into rockets now. So
can we get back to the guy?
I'm having
back
a
to the
discussion with about 6 people here, right? Now you can't suddenly everybody pile in on me, yeah? And then when I ask a question or decide to talk to the person or
you can't change subjects like that, Alan. We're not going down this rabbit hole.
I never changed. You started talking about P900s and fucking all sorts of thing, and Red came in talking about mathematics and that, changing the subject.
That was not changing the subject, you fucking idiot.
Yeah, that actually was right on the subject we're talking about.
And he comes in and insults me.
Ali, we're talking about Sextant and math, and then you start talking about it's not.
Yeah, we're talking about Sextant, math, and angular diameter. So everything's been consistent. And we started talking about Newtonian mechanics, which we were going to get back to.
No, we'll get back to that, yeah, because definitely. But let me we'll go back to the Sextant. Let's finish with that, right?
There you go.
I'll finish. I'll do a closing statement on the Sextant.
There you go.
What's his name? Geist can give his closing statement, and then we'll move on to Newtonian mechanics. If that's
Sounds good.
Right. Okay. So a sextant, all it does is measure the angular, where the angular position of a star, right?
Star, sun, or moon.
Star, sun, and moon, right? Okay. So
over the angle over the horizon.
Do with longitude, right? You have to. Well, it's got fuck all to do with longitude and latitude, right? You're just looking at a star. Wait a minute, let me finish. Like
because you're wrong. You're fundamentally wrong.
No, in your opinion. Right,
no, it isn't.
A sextant.
People have been using this thing for 230 years. Every one of those people who's ever used it, the thousands of people, is that also their opinion?
Yeah, I mean, the people know how to.
Can I now finish what I'm going to say before I get into?
Yes, but if you're fundamentally wrong, I'm going to stop you when you're fundamentally wrong. I'm not just going to let you continue on and then you think it's all over. It's not going to work like that.
In your opinion, I'm fundamentally wrong.
Oh, I think
you are fundamentally wrong. The people who use them.
Well, hang on, that's everybody's opinion.
Okay, I'll quote a guy called Leonardo da Vinci. Just because everybody says it's so doesn't necessarily mean it is so.
Well,
okay?
That's true.
Yeah, and
so you finish.
Does that work for flat earthers? If the entire world says it's now a flat Earth, does that still make it right?
But the reality is,
no, it doesn't. No, it doesn't.
Okay, good.
Alan, there's something called argumentum ad populum when you're talking about the popularity of something in the average public. But when there's a scientific consensus, that's not a fallacy. If every scientist, or not every, but of the vast majority of every scientist in the world, the vast majority, 99.9%, say the Earth is not flat.
I want to see that. You've made a statement. I want to see proof of that. That
99.9. There's only about 500.
They're sitting amongst each other arguing about this.
Let's get back to the Sextant and stop talking about popularity contests.
Guys, hang on. All you have to do.
Want to be popular, man.
All you have to do is demonstrate by giving us one scientist that we can talk to that maintains a flat Earth, and I only know of one, and he's been already debunked, and that was an astrophysicist who did a very shitty job on actually it was a geocentrist. It wasn't even a flat earther. So how many famous scientists
done a shitty job.
How many famous scientists do you know that are flat earthers? Because I know of none.
Will I have time to answer that? But nobody's going to interrupt, or can I answer that one?
Sure.
Right, okay.
Damn, can we get back to the fucking Sextant?
Never mind.
Guys, he's not understanding the Sextant, but he's not.
No, I do understand the Sextant.
You don't understand it.
It measures angles of stars, sun, and the moon. Am I right?
Yes, over the horizon. Yes, and then what?
Over the horizon, and then you have to look at the almanac to find out how long. But it doesn't measure. It doesn't measure that. It's
Doesn't
measuring
measure-
angular sizes. That's all it does.
Yes, it measures angle size, and then because of that angle,
And then
it'll
a
put you on the
book-
surface. Because it.
And then there's a book. Then there's a
Yes.
book you look at that
Yes.
says, "Oh, by the way."
No.
Yes.
It's not. It doesn't say that. You have to calculate it. You
Okay,
take many different calculations. You got not only deal with the angle, you deal with refraction, you deal with dip angle. It goes from there. I put the link in the chat. See if you guys want to take a look at it.
So refraction, is a constant.
Refraction.
Yes, 10 millibars.
So refraction is a constant, yeah.
No,
But no,
10 millibars.
10
Hold on a second. Hold on a second here. Hold on a second here.
What happens if it's not 10
Hold on a second here.
millibars?
Hold on a second here. I will answer that. It is a constant with inside the calculations table because a sextant has a margin of error. That a margin of error is accounted for in the refraction table.
Right. Okay. Now, a margin of error.
Okay. Every time you go right, okay, you're dismissing it without addressing it.
No, I was going to address it there. And you keep.
Okay.
This is what you keep having. This is what I'm struggling against here, is because every time I make a point, right, is someone interrupts and then I lose my point. So what is the
Because you're
point?
wrong.
Well, I think
You're wrong.
Yeah, I think what it is
Well, no, that's in your opinion that I'm wrong, right?
Okay.
You are wrong.
At this
Well,
point,
no,
It's-
but that's
Yeah,
your opinion.
it's
That's
okay.
all it will ever be, is
You know
an
what, we're
opinion.
moving
No,
on
but-
from the sextants because we're
Yeah,
moving
let's
on-
go.
we're-
Let's go
yeah, we're
to
moving on from
Newtonian.
sextants. Guys, he doesn't
Yeah, let's go
understand
to
it.
Newtonian. Yeah,
Yeah,
I
he
don't
doesn't
understand.
Okay,
it.
okay,
Yeah,
okay,
that's-
okay.
he doesn't
Give me
understand.
okay. If we're
And
moving
you
on,
don't
if
understand
hold on,
that point.
I do understand how the thing works. I've been using it since 10. You have never used one, picked one up, so I can definitely use my opinion. It outweighs your opinion. So, anyways, chat. I'm gonna go ahead and hang up. I gotta get out of my hotel
My
room
dad
pretty
is
soon.
bigger than your
Thanks,
dad.
guys.
That was a
Hey,
good idea.
but I do
Thanks,
appreciate
guys.
take
Yep,
it
thanks,
easy
guys.
down here in the
Before you leave, guys,
chat.
before you
And
leave,
y'all
guys,
take it easy.
Thank you, guys.
guys,
Thank
before
you.
you leave, before you leave, the takeaway from it is that he was unable to demonstrate using.
I'm here.
Yeah.
Here.
Yeah, no,
Alan was unable. Thank you. A bit of respect.
I said
Come on,
he.
man.
That's a pronoun referring to you.
No, but I'm a noun. I'm not a pronoun. My name
He is a
noun.
pronoun. Okay.
It's a proper. Alan is a proper noun.
Wow.
right?
Okay.
That's a name.
Anyways, Alan was unable to demonstrate how to use a perception
Thank you.
properly on a flat Earth. Okay, that's the takeaway.
Okay, I just like I said, I just want. I'm right now.
You're
I'm
not
talking
gonna
to.
get. Oh, 1-0.
Right now, I'm
Okay.
talking to the chat. Hey, chat, thanks for listening. If you guys want to, I put it in the chat on the side, the links to the almanac and the calculations. So if anybody wants to take a look at it and learn more about celestial navigation, feel free, or just look for me in ED. But May 17th, I will be traveling down to Antarctica for 13 months, and that supposedly doesn't exist, but
I never
you'll
said
take it easy.
doesn't exist.
Hold on a
Stop
second.
that. Of course
So,
it
once again,
exists. So it exists.
once again,
It exists.
Allie,
Of course
I'm
it does.
talking. Allie, I'm talking. I gave you the courtesy.
You've been interrupting me all the
Any-
time, and now what I'm going to do to
I'm not
piss you
talking
off
to you,
is
Allie. I'm
gonna
talking to the
start
chat.
talking over
I'm
you.
talking to the chat,
Oh,
Allie.
But I'm talking to you. Blah,
Okay,
blah.
okay, I am done. You all take it easy there, chat.
All right. Thanks, guys.
Later.
All right. So moving on. All right. Thanks, Reds. I know you're at work. What time are you off, Reds?
Thanks, Red. Thank you.
What time are you off?
I get off at 11 o'clock at night because it's a 12-hour shift today. So let me just say this before I do leave. Is that yeah? I'm sorry, Allie. Some of us have jobs. Okay, so when it comes
I have
to
a job. I've got a job, mate.
yeah, I'm actually at mine. So shut the fuck up. Anyway, when I actually come back to this,
Well, what's that got to do with? You've got a job. Excellent. That's so the earth must be round then.
All right. Let's finish because he's at work. So let him finish, please. Let's go ahead.
All right, thank you. I'm going to go ahead and watch this hangout later, and I'm going to see if he actually gave an actual answer to the angular size of the sun argument. And also, Ali, if you want to learn more about how rocket launches debunk flat Earth, come over onto my channel sometime and we'll chit-chat. Till then, suck a fat one.
All right. Thanks, Reds.
Is that a big doobie? You mean a big fat spliff or what? Or what?
I think he means cock, but I don't know.
Oh, right.
We never know with
not the
Reds.
crack pipe, not the crack pipe he smokes. No, okay.
All right. So we're going to move on to mechanical.
Excellent.
Newtonian.
Newtonian.
So you made a claim. You said we don't use Newtonian physics anymore. What gives you that impression?
No, in space, right?
Yes, we use Newtonian physics in space. Yes.
Right. In what way? To do what?
Are you familiar
Newtonian
with?
physics is the basis of space travel. It is the foundation upon which
Yes, orbital
rocket
mechanics is
trajectory was
based
figured
upon
out.
Newton. Yes.
But it wasn't. I thought it was what's his name? That not Kepler. Was it Kepler? Kepler done orbital mechanics, wasn't it?
Yes, yes, but we're not. Yes, but Kepler's.
Right, so don't give credit to some guy that didn't have anything to do with doing orbital mechanics, right?
No, Newton has everything to do with it.
Mechanics in space.
Familiar with Newton's? Are you familiar, Alan? Are you familiar with Newton's canon?
Now you.
Is the yes or no question?
Yes, I'm very
then
well
it was Newton that started the first to develop the principle of orbital mechanics. Newton's laws and Newton's laws of motion are the fundamental basis by orbital mechanics and what happens in space. Okay,
and then Einstein came along and changed it.
Einstein did not change them. Einstein added to them. Do you know what the difference between? Do you know what the difference?
He never added to them. In what way?
Do you know what the difference between Newtonian physics and relativity is? Can you tell me even the difference between general and special relativity?
Yep. Okay, then I would. Relativity uses an imaginary the reference frame, right, is in the center of a spinning object. That's a reference frame. It starts and an imaginary laboratory where
that was completely incoherent nonsense. First of all, I asked you what's the difference between general and special relativity. There's two types of relativity.
Right. Oh, right. Wait a minute. I know this one. Wait a minute.
Okay, the fact you even have to think about it demonstrates you really don't have.
No, I do know. Listen, it could be down to bad memory, mate. You don't know the. You're making an assumption there.
You're demonstrating you seem to have no proficiency in this area.
No, well, I know for a fact that in special relativity, right, you have to use a virtual laboratory.
What?
Where? Well, are you going to argue?
Yeah,
right, so you're saying I don't. Sorry, yes, you do. Yes, you do, because you can't.
What does that mean?
Well,
what do you mean by virtual laboratory?
It's called a virtual laboratory, right?
Go on.
Right. Where? Thank you. Where all circumstances are calibrated to that virtual laboratory. So, for example, they would take for example, if they wanted to do a calculation with the moon, they would take the moon into the virtual laboratory, right, and then do its measurements as it had no forces acting upon it.
And that's what you think of special relativity is?
Wow, this is
Jesus
completely
Christ, wrong. Alan. I don't mean to be disrespectful. But
no, sorry, be disrespect. Don't change your habit of a life, mate. You continue.
Fine. I've met some dumb people.
Continue, buddy.
But that was one of the dumbest, most incoherent, nonsensical bullshit answers I've ever had in my entire life.
Okay.
What the hell was that?
Special relativity.
That didn't even come close to what special relativity entails.
But that's what you have to do. You have to take it into a virtual laboratory.
No.
Yes, you do.
Absolutely no.
No. Would you like me to explain to you special relativity in a nutshell?
Yeah, go on then.
Okay. Special relativity deals with the fact you have what's called time dilation as you approach the speed of light, starting at about 20% or 0.2% of the speed of light. It's based on a formula called the Lorentz contraction, which is 1 divided by the square root of 1 minus v squared by c squared. You're sitting there shaking your head, but yet I can guarantee it. You do a simple Google search, you can be informed what special relativity is. Special relativity has to do with velocity. Okay, the general relativity deals with gravitational forces being a result of something traveling between the shortest distance of a geodesic path in space-time, in curved space-time.
Yep.
Okay, so there's
two different types.
There's two different types of relativity. I asked about special, and you did not mention anything about Lorentz. You didn't mention anything about velocity. You didn't mention anything about the speed of light. You clearly have no idea in the world what the hell you're talking about right now, right?
But you have to, for special relativity, for you to take measurements, right, you have to go into a virtual imaginary laboratory and take the measurements from there. Are you saying no?
Yes, no, absolutely no. That's completely nonsensical.
Like saying you have to consult a pink bunny. No, you don't.
I would say then that you haven't read about it then.
Oh, I've been reading it since I was in junior high.
All right.
I've had astrophysicists on this program.
Frame of reference. What frame of reference does he use?
What does frame of reference have to do with special relativity? Frame of reference is deal with general.
Because it's in there. Because a frame of reference is the observer.
We're talking about.
Right. Listen, I'll tell you. Let me answer. You asked me, right, what the frame of reference is, and that frame of reference is the object or the person that is doing the observing in a virtual
Not
laboratory.
virtual. We're talking about what's called
It
an
is
inertial frame of
virtual.
references. Okay.
It is a virtual laboratory, my friend. I would go and check that out yourself.
No, it's not.
No, you're saying it's not. Well, I'm saying that you're wrong.
What it is,
and
what
you're
it is you
ill-informed.
have you ever done transforms? Do you know what a transform is? Galilean transfer or anything like that? Matrix? Okay.
Is it a sum? Is it a sum equals 7 over the fucking power of 65 or something like that? Is that what that is? Or what is it? Explain it to me.
No. A transformation is where you take an object and you move it within an X and Y, Z axis. You have it's called a transformation or a transform. There's different types. There's Galilean transforms where you can actually take everything and make that into the center of the solar system or center of the universe, whatever you want to make it to be.
Thank you. A virtual place to do your measurements.
It has nothing to do with virtual.
Nothing to do with virtual anything. No.
It's
Yeah,
imaginary then.
No,
It's
it's
not
not imaginary. These are
You
basic.
cannot measure the speed of an object if you're traveling. If you're on a traveling
what?
object, you can't. If you're traveling on an object, right, and you try to measure another object that is traveling, you can't measure the speed of it.
Sure, you can.
Yes.
Okay.
That's
Why
just,
do you-
No, you
that's just
can't.
retarded. I mean, that's basic
No, you
physics.
can't.
If
No,
you're
you
in a
can't.
train,
Tell me,
traveling-
explain it.
if you're traveling in a
Well,
train,
explain
if you're okay, listen. If you're traveling in a train and you're going 100 miles an hour, and another train's right next to you going 100 miles an hour, I could do 100 miles minus 100 miles. The relative velocity between us is zero, right?
Right,
Or
but what happens if it's right? Okay, then. But what happens if it's traveling the other way?
then it's 200 miles.
So how do you find out the speed of that other train if you're traveling at 100 miles
Put a laser to it.
and it's
Look at the
traveling
Doppler.
faster than you? And
Look
it's
at the
traveling
Doppler.
faster.
Look at the Doppler shift.
What the Doppler shift? What the fuck are you talking about?
Do you know
The
what a Doppler
Doppler
shift is? Yeah, do you know what Doppler shift
You
is?
just explained you just well it's a differential
it's
in
called
a
redshifting
time.
and-
It's a time. It's
Yeah.
it's something to do with the distance. It's a difference between time
Yeah, I hope you
measurement or
never
something like
become.
that, right?
I hope you never become a professor or a teacher, dude.
Well,
it has
it's
to do
like
with
when the car, right, go on then. Go on. It's just, they use the analogy when a car beeps its horn and it goes meow.
yeah. Do
right.
you know why it does that?
Maybe to do with the speed of sound, maybe.
No, it has to do with the fact that the
no.
wavelengths are getting longer or they're getting compressed, depending on if it's going away from you or getting near you. It has to do with the size of the
Yeah,
wave
so it's just,
from the
yeah, but
drop
it's
to
to do
the
with the
crest.
speed of sound, right?
No, the speed doesn't change. Speed of sound is a constant in a vacuum.
Oh, in a vacuum,
Well,
yeah. Well,
The speed of sound certainly is a constant in a vacuum, but it's zero.
all right. So how does
Yeah,
sound
that's true.
travel?
I'm sorry,
How
yeah.
does sound
Yeah,
travel?
sorry, but
right?
you're right. That's true. It is a constant.
If
It's zero.
sound,
Somebody
if-
somebody gets it. It's true.
if the speed of
I
sound
didn't mean
is
that
a
in a vacuum.
constant, right? How come sound travels faster
In air.
through a solid object than air?
Okay, first of all, I meant to say in air at zero. What is it? 0 degrees STP, standard
Right,
temperature
so
pressure.
it's not a constant then,
25
right?
degrees Celsius, whatever it is. It is no, it's a constant, but it's based upon your fact you have a standard pressure, temperature, and relative humidity.
Constant in a given.
No, but it can't. Listen,
Yeah,
it can't.
But
it
the
can't-
reason why sound
that's
travels,
imaginary.
the reason why
That's
sound,
imaginary.
you asked a question. The reason why sound travels through certain objects is because usually those objects are denser, and the sound waves can travel faster through them because air is a more rarefied
Therefore,
medium.
it's not a constant.
I just said, and air at standard temperature and pressure, it's a constant. Just because it could travel in different speed and something else doesn't make it not a constant anymore. Just like the speed of light in a vacuum is a constant, but light will travel different speeds through different mediums.
So light's not a constant then.
Yes, it's a
And
constant.
near sound.
Oh, Jesus
Aye,
Christ.
no, a constant in air, right? And
It's constant for the material that you're dealing with.
It's constant. It's a constant, but it's a different speed. It's a constant, but it's a different speed going through this bit of tobacco or a brick wall or any. So it's a changeable constant.
No, it's not.
Dithering
Okay,
what matter.
let me explain to you basic physics here. When we say it's a constant, that means given the conditions of a vacuum, right? Light's going to have one speed. It cannot change from that speed in those conditions. You change the conditions, now light could change speeds, but you're not changing the constant. The constant is a single number that equates to what speed travels in a vacuum. Now, do you
Perfect.
understand?
So it's a constant in a vacuum.
Yes.
Thank you. Well, I've got one question. Why is it galaxies far away are traveling faster than the speed of light?
They're not.
Because here's the thing, it goes exactly to your train analogy. We are moving in one relative direction. They are moving in another relative direction. And that change, that opposing, can lead to something appearing to move faster than the speed of light, despite it is in fact.
Yeah, it's just an apparent. It's called the radial velocity that they're going with respect to us gives them a higher than 1 redshift. So it's just it's an apparent speed that they're going, but they're not actually going faster than the speed of light.
Right. So is it the galaxies that are moving, or is it right? For example, right, if we're heading towards a galaxy, because we must be heading towards one galaxy that's apparently traveling away from us, right?
We're heading toward Virgo.
Right, but we must be doing that. But and if we measure that, that's going faster than the speed of light.
No, nothing can go faster than the speed of light in a vacuum. That's a fundamental thing in physics. You have to get that through your head first. Nothing travels.
No, but
faster.
I'm quoting science here. They say that.
Yeah, I think he's talking about. I think he's talking about relative.
He's talking about relative velocity, and that's not the same as going faster than the speed of light. There's certain things that make an appearance of going faster than the speed of light.
No. But that's I think I disagree there. That's not the scientific definition. But that's not the scientific definition. You're just giving an opinion there.
This is not opinion. No, it's not opinion. This is fact. Nothing can go faster than C. The value of C. Do you know what the value of C is?
Galaxies go faster than C.
No, they do not.
Well, I think, Steve, what he's saying is if we take the expansion of the universe,
yes,
the most distant galaxies, they are in reality receding away from us faster than the speed of light.
No, that's not how it works.
Yes, they are. Oh, yes, they are.
They're not.
Bingo.
What's happening is
thank you.
It's an apparent. It's an apparent. Apparent does not mean that's actually traveling at that. What's happening is because there's expansion of the universe.
You're changing definitions yourself. You're
not
even talking science.
Listen
now.
to me very carefully.
You're not even talking science.
Okay.
You're not even talking science. You're making
Alan,
shit up now, man.
Okay, you know what, Alan? I'm just going to say goodbye to you. I'm done. So I'm not going to be put up like that in my own hangout. This guy came in to try to teach us flat Earth, and instead of doing that, all he wanted to do was troll. And I've kind of had enough with that. So we can continue on and talk about this, but yeah, I'm not going to be talked down to in my own hangout. People know that. I'm certainly not going to be talked over. And if somebody wants to have an explanation, they need to shut the fuck up and listen. So anyways, thank you guys for watching, though. 123 people watching. I think it was actually kind of interesting, but it wasn't going anywhere. Yeah. And once somebody gets in that troll mode, the conversation's over. So
it has an astonishing lack of understanding of physics, but
astonishing,
an incredible arrogant presumption that he knows it.
Yep, just astonishing.
Yeah,
Steve,
going
back at the whole expansion of the universe thing, those galaxies, they are in reality moving away from us faster than the speed of light.
No, they're not. It's not in reality. What's happening is because of the universal expansion, there's a Hubble's constant, right? 71 megaparsecs per second. That's the acceleration due to dark energy causing the fabric itself to go faster. Now, because relativity allows for space-time to exceed C, okay? The objects inside in the space-time is not ever traveling faster than C.
Yes, I know that.
Okay, but hang on. Let me finish. So, because you know this, it's the same thing with the accubarometric, right? With the accubarometric, we're at the warp bubble, which is very similar to like Star Trek. The way to propel somebody to another star, the object itself will go much faster than the speed of light, but it's not actually moving faster than the speed of light. What's happening is space-time is going faster than the speed of light, and that object is moving along with it, riding the crest. Yes. So it's just an apparent thing. That object itself never goes faster than the speed of light relative to itself. That's the point I was trying to make to him.
What I'm trying to get at here is if you had a spaceship that could go the speed of light, you will never catch that object because it is in reality moving from you faster than the speed of light. The space you would have to traverse to get to it is moving away from you faster than the speed of light.
Correct.
That's kind of what I'm trying to get at. It's not just an observation that's sort of an optical illusion. It is in reality moving away faster than the speed of light.
No, so that's why I disagree. It's not actually
not within
relative to what? I mean, relative to us, it appears to be, but relative to its own frame of reference, it's not.
Not just appears. In reality, it is because you couldn't reach it if you sent out a probe at the speed of light.
relative to
Never
us.
catch it.
Relative to us.
Relative to us, yeah, you would never be able to catch it. If you sent out a probe right now, you would never be able to catch these.
Right, it's going to be outside of our event horizon, but we're never going to be able to reach it. Right. There are points of the universe.
It's not just an apparent effect; it's in reality.
No, I agree. It's in reality, sure. That's not what I was saying. I was trying to explain to him that within his frame of reference, an object's never going to move faster than c.
Yeah. In reality, you'd never be able to catch it. However, also in reality, I don't know why we're putting this phrase in front of everything, because we're not talking in fantasy. In reality, it's not moving faster than c.
Right. Thank you. That's exactly what I was trying to get at.
I think we're just talking past each other is all it is.
No, I understand what you're saying, but I think you're wording it a little weird.
I didn't want it to sound like this is just an observation that isn't actually comporting to reality.
Yeah, and by the way, somebody noted in the side chat. Yeah, I meant the cosmic horizon, not the. But you know what? I don't mind calling. Maybe I'm wrong. It is the cosmic horizon, but the cosmic horizon is in a way an event horizon.
But by the way, I think
it's our observable horizon.
Yeah, it's our observable event horizon, right?
I think where Ali was going with that relativity thing is he was trying to get at the fact that there is no absolute. We're not absolutely relatively moving to anything. We're just moving relatively to other objects, which I think where he was going about, if you're coming at a train, you don't know whether you're moving towards the train or the train is moving towards you, or you're both moving at each other. It's all dependent on, what your reference frame is. I think that was what he was trying to explain.
Okay, well, he didn't even understand basic stuff. I mean, here's the funniest thing. We all know basic vector. We all had vector analysis, right? So we all know how to do vectors. And if you take a train 100 miles an hour and another train is going 100 miles an hour, we know the relative speed between them is 0, right? And if we know that they're moving toward each other, you just add them, right? Summation of the scalar speeds, right? We all know that. So 100 miles an hour, two trains going past each other, the relative speed between them is 200. We all agree?
Sure.
Now, here's what he wasn't going to understand. This is what we're trying to get to, but he was already confused at that point. That if you're traveling at the speed of light and somebody passes you at the speed of light the other way, the relative speed between them is not 2 times the speed of light.
Yeah, that's right. Or you could take it down to non-luminal speeds and say one's moving at 3/4 of the speed of light this way, the other one's moving at 3/4 of the speed of light that way. If you put one of them in a stationary frame of reference, you cannot then say the other one is moving at 1.5 c. It isn't.
Right. Right.
At that point, you need to go to the velocity addition formula, which is a 3-dimensional equation. You can look this up, but it's
yes, you're right on track, and that's what we were going to try to explain to Alan, but he was so far lost over basic vector addition that you think he was going to be able to understand what you were about how to do luminal speeds.
I would fail to teach that to Alan.
Yeah. So I mean,
he doesn't know special relativity from general. He thinks special relativity has to do with a virtual laboratory.
That was just scary.
He thinks he can relate relativity to trains. Like, it's just, I don't even know where to start.
It was bizarre. So fundamentally flawed on so many different levels. And again, one thing I noticed with the flat earthers is that I think it was who was it? Epistemology. You had said the arrogance that they have at their own incompetence is amazing. That they will actually think that they know something, and then when you ask them a very basic question that everyone in my audience would probably know. We have 120 some odd people watching. I guarantee it. Even Blue in the audience, who's not that bright, would know relativity. Sorry, Blue. He did.
But I'm willing to concede.
But I mean, it is funny. This is like general kind of stuff. I mean, most people may know the specificities of these things. I don't think they've ever worked with Lorentz contraction. I have. Most of them have done some transformations. But simple vector addition just of scalar quantities, it's not that freaking hard. So anyways, I'm opening this up more. Oh my God, we just got a lot more viewers. It's just I kicked him. We actually got a lot more viewers. If you want in, I'm happy to let anybody in. Yes, Stizer, you can come in, but you've got to send me the link or the message directly, and I'll give you the link to come in. I'll keep it up for a little while. There's a few other things I want to talk about eventually at some point, but if you want to come in, let me know.
Yeah, I think with these flat earthers, what we need to do is just focus on a simple topic, not get into the details of Einstein versus relativity versus Newtonian physics. That goes like so far beyond what you're going to.
He brought that up himself, and I don't think it was an attempt to deflect. He was actually saying that, well, the reason that you don't see X or Y phenomena on this Earth, which is to him flat, is because physics is different down on Earth than it is in space.
You know, I was
And
trying.
as an example, he says, well, we chucked out Newton when Einstein came along. Well, that's wrong to start with.
Right.
So,
Right. But how do you fix that level of stupid?
yeah.
Well, I mean, it's the same thing as quantum eraser saying we chucked out Newton when we discovered quantum physics.
Oh God, quantum! Oh my God, quantum eraser. That guy is just mental.
I just like the way you do the building. When you talk about the building, the sun going up, when you go up in the building, that's easy. Anyone can get that.
No, they don't. That's a problem. I mean, we pointed that out to people many times.
Well, we had this Northern Irish flat earther in the hangout on, it was Saturday or Sunday, and we were showing him this time lapse of this mountain I think it was Mount Fuji or something, as the sun was going off the, illuminating the tip and moving slowly down to the base, along with showing him, the rocket trails where they're in darkness down at the ground, but you can see the rocket trails in full sunlight. And we're saying, well, how is this possible? And they come up with some ad hoc explanation. We even drew diagrams and things for them, but it doesn't really doesn't get you anywhere, because they'll just come up with an ad hoc explanation for it.
Right. And by the way, people tell me not to let Stizer, and he's triggered. Stizer actually sent me a message. You're wrong, Steve. You're wrong, Steve. Let me tell you something. Stizer telling you something you're wrong means you're absolutely right. Just do the opposite. I mean, he has a propensity to be like 180 degrees opposite of what the correct answer is. So just point that out.
I like Ali. You say, well, how come this phenomenon occurs? And he says, well, I'll tell you why. Perspective.
Yeah, that's an answer, right?
Yeah.
Like, how is that an answer?
Well, that was the thing when we were talking about
flat Earth magical catch-all.
When we were talking about the angular size of the sun. Okay, we'll grant you that the atmosphere has this magical magnification ability to perfectly zoom in as it moves further away so that it stays the same apparent size. Now explain the azimuth. What's the phenomenon that's making for the azimuth that doesn't change, on the equator, on the equinox, right? Because if you look at any flat Earth map, then the azimuth would be changing throughout the rise, zenith and set.
Some kind of horizontal refraction or perspective again. I don't know. But
Well, they throw out these magical words like they somehow are an answer to everything. Oh, it's perspective. Oh, it's refraction. Oh, it's atmospheric disturbance. But it doesn't tell you anything. I mean, most of us you guys have telescopes, right? I assume, right? So we've worked with things like azimuth and declination. I took astronomy in college. We were familiar with the celestial sphere, but when you're dealing with a flat earther, I don't think they even can understand the concepts, right? If I said, "Hey, point to the zenith," they'd be lost, right? So you're trying to cram in a lot of information with these people in a very limited amount of time, and the worst thing is when they get arrogant about what they're trying to say, or they bullshit like he did. When I asked him about special relativity, the amount of garbage coming out of his mouth was worse than anything I've heard from him in true empiricism. It was just nonsensical rambling. And at that point, I know the conversation is diminished to nothing, right? So you guys are mad I kicked him, sorry, but I have no choice at that point. It's just not worth it.
well, Steve, you did just start making stuff up. I mean, come on.
I know I do. Yeah, you know me, right?
Oh, jeez.
I mean, I couldn't even finish a train of a sentence, right? Just to explain to him something, because he obviously thought he knew more about it than everybody here. I mean, when he was learning about sextants, I don't think he ever knew much about sextants. I don't know. The only reason I recently learned about sextants was only because Hogtie had brought it up in a chat just recently. So I said, you know what? I know what they are. I kind of I have a basic understanding of how they work, but let me read up a little bit more on them, and I did. So I'm like, oh yeah, okay, I totally get how this works. But I could tell that he never has.
Oh, you mean you were being intellectually honest about something?
Yeah, don't let that get out, dude. Yeah, don't tell people that. It'll ruin my reputation, because I've been told by the Clown Car Posse that I have a reputation of just making shit up and lying all the time. So, yeah, don't tell them the truth. It hurts. Stizer, I said you can come in, but you have to send me a request on the outside chat. And I guarantee it, I'll give you a few minutes, but if you tell me I'm wrong and you start spewing your nonsensical bullshit, I'm not really in the mood for it. I wasn't feeling well yesterday. I'm not feeling too great today too. So, and now Stizer's saying he won't because you faggots said don't. Did I not say like 4 times Stizer can come in? No, Stizer, you sent me a message on G+. Send me an instant message, right? Not quit sending me links on Google Plus posting. Okay. I've asked 5,000 times. Don't send it on Google Plus. Send it to me as an instant message. Okay. Because what happens is if you send me on a post and you forget to make it private, and I put the link out, then I get trolls in here, and I get people, you know, bombing and stuff. So I can't take the chance of putting a link on a Google post. He just can't figure this out.
Oh,
So I just says it's private, you fucking idiot. Well, that makes me want you to come in here. Actually, just because of that, you get a timeout, Stizer.
seriously.
Yeah.
To be this tall to ride this ride. What the hell, man? It isn't complicated getting into a hangout.
I know it's not.
Sitting at fucking Google Hangouts messaging it.
Yeah, I know. It's just funny. I mean, I make it very simple for people, and they're like, "Oh, you know, yeah," and I'm like, "Okay, whatever, man." I don't have much tolerance. They do, don't they, Jared? Though
Having anger management issues coming into the hangout, it isn't going to go well when he gets here.
yeah, probably not.
Yeah,
Right?
true.
Yeah, good point. I know. I got 120 people, and nobody's requested to come in. I'm actually really surprised.
So what's the next conversation going to be about? Get another flat earther in here?
Well, they're far and few between. I am trying to work on another video with Orphan Red. What happened was I used a different editor, and I didn't realize that the editor only compiles half of my video. So I got to figure out a way to stick it in another editor. And I'm trying Adobe Premiere, but the learning curve is very high. And I got a few other ones, so I'm going to figure out something. But did you guys like the last one I did? That was the production value?
Yeah, I liked it. Yeah, it was good. The 80s one?
Yeah, the 80s one.
Yeah, it was good.
It's only
And you
3
got some
minutes,
music.
but
You got music that was close to 80s sounding.
yeah. Well, somebody had actually, it was Tal Steady Alpha actually said, how about challenging you to be able to do a video with music playing in the background? I was like, accepted. So that was for Tal Steady Alpha.
Yeah, it was pretty good. I like the the best of too. I was binging out on that. I need more.
Yeah, that's one of my more popular videos. But okay, here's a story on that. I tried making a best of 2, and well, I was doing it in chronological order, right? And so this is going back to like 2015. And I got to the next 2 videos, and they were mostly with a guy named Balthazar. And I got to tell you, there was so much stupidity in there, I couldn't really narrow it down to a best of 2. There's just so much Balthazar was saying that was so wrong. It was very difficult for me to find out what I really wanted to highlight, so I gave up. So maybe I'll revisit it.
My phone's
What's
about to
that?
die. I'm gonna head out, guys.
Hi, Jerry.
Catch you
Thank
later.
you.
Get the puppies going.
You know what? I think my chat froze. Actually, maybe I am getting requests. I don't know. Let me reset this. Oh yeah, it did freeze. Caleb says, what's that? Let's see. Caleb says you should talk about the expansion of space and what, if anything, space is expanding into. You know, that we kind of did a little bit. You know, somebody had messaged me on my Facebook saying, "Hey, Steve, isn't it true or something that during the initial inflation period of space-time, that space-time went faster than the speed of light?" Yes, actually, yes. But relativity allows for space-time to go faster than the speed of light, right? Which would have confused Alan to no end. He would have been like, I thought you said nothing can go faster than the speed of light. Well, nothing with mass can go faster than the speed of light. There are exceptions. Space-time itself can't go faster than the speed of light. But as far as expanding into something, it doesn't expand into anything. That's the problem with it. Like when they say Big Bang is an explosion, it's not an explosion because there's nothing to explode into. And the definition of explosion is something going from a higher region of pressure to a lower region of pressure in a volume space, right? So Sean Hufford. Oh, here you go. Yes, Sean. I didn't see you, Sean. I'm sorry. Yes, Sean. There you go. Blue. There you go. You guys got leads. And by the way, does anybody know much about redirects? I got a redirect problem. I was downloading something and I thought I sandboxed it. I did sandbox it, but for some reason it still fucked me up. Now, certain times when I press on something, it redirects to another link. I've tried hijack this. I can't seem to find the problem. But if you're an expert on redirects, let me know and get with me later.
Hello.
Hello, Sean. So what'd you think of that little ridiculous diatribe?
Oh, I was wanting in as soon as he started to go on special relativity. I came into the live feed like right before Red left.
Yeah.
Because I was coming home from work. But
Were you just coming home from the virtual laboratory, or?
Oh my God! Yeah, the virtual Walmart.
Okay, you know about this stuff pretty well. I mean, even though yeah, you're not really in a science field. You are one of those lay people that just have a really good aptitude for it.
I'm just one of those lay people that did a whole lot of reading through my whole life.
Yeah. So let me ask you: when I asked about special relativity, did anything he even say remotely?
Not even close. I mean, he was just making it up on the fly, I think.
Pulling it out of his ass, literally. And so I don't have time for that. Once somebody starts doing that, the conversation is done in my book, right?
I mean, for frick's sake, if you don't know, just say you don't. Most people don't. Most people know nothing about relativity. It's fine, right? What the hell? You don't expect it to.
I mean, I think the new intro and outro song to pretty much every video I'm going to be making from this point on will fit him nicely.
So
I would like to
say
what a layman knows about general relativity. But since Steve said I didn't know anything about it, so here you go. Here's all I know.
Relativity means that you can't fuck your cousin.
No.
No, that's special relativity for now.
Go ahead, Blue.
Well, basically what it is.
Special exceptions for that.
Very special relative.
Very large objects warp space and time. Warp space time. Basically, that's what it is.
That's general. We were talking about special, Blue. But you were so close.
No, you asked about general.
I asked about special, actually.
No, you asked about... Oh,
guys, what did I ask about, special or general?
Special. You initially, 5 minutes ago, you when you said I wouldn't know it, you said general.
But even in your definition
of course. Never mind. Go on. And let me talk bad about Stizor and the other limey in a second. Hold on, I got to get some weed.
You know what? Hey, Blue, I got to tell you. We're going to go way off the topic here, but I watched a video by Jason Burns this morning, I think it was.
Which one?
The one I actually agree with him on. He was actually talking about Satanic Atheist.
Oh, that is.
And he actually made sense.
Yes, I know.
I know you. He's your hold
on, just one moment. Do you know where Jason Burns heard about Satanic Atheist losing his channel? By watching my show.
Oh, okay. I know he's your nemesis and everything, but you go on air to admit that Jason Burns on this particular topic, he was actually right?
Oh, I already said so in the comments that, well, he did say one thing. It's like, later in the video, most of you didn't see it, but it's like, oh, well, most of you atheists aren't standing up for Satanic Atheists. And I was like, you little fuck, you heard about it on my show. What do you mean we're not?
Yeah,
no.
That part doesn't make much sense, but I mean,
I have a strange symbiosis with Jason Burns.
But he did agree that Satanic Atheist. The only thing I disagree with Jason on is not that I really disagree with him on it. People have to realize that you don't have freedom of speech on YouTube. You just don't. I mean, you're at the mercy of YouTube. You're on their platform. Whatever they say goes.
Well, this is what I tried to. Well, I mean, I don't know how it works, and I don't want to rehash this one. I really don't. But doesn't YouTube own your video, and therefore, I mean, obviously you can't.
No, you have the rights to your video, but you're using their platform. You could take the video and put it on any of their platform. They don't own your video. But here's the thing.
But when it's on their on their platform, don't they own it?
No. But they could determine whether they want to have it on there or not. But the point being is,
in the agreement, you're basically granting them a license per the agreement that you click OK on.
Yes. But here's the thing: you don't have freedom of speech, but that doesn't mean that YouTube should really go around taking channels down because they don't like the content of what somebody's saying when it's not violation of TOS. Can they do it? Yeah, they can do what the hell they want. But it does set a very bad precedent. Because if they start doing that to Satanic Atheist, then they could do it to other people. And what they did to him, I think, was bullshit. Now, I know his videos are controversial, but he's not advocating for anything of the things that he's actually putting in the video. It is satire. It's supposed to be thought-provoking, right?
If I can actually expand a bit on that whole freedom of speech thing, Steve.
Yes.
Freedom of speech is stating that the government cannot impede your freedom of speech. Private corporations or private businesses or even private homes can, because they're not a government entity.
Right, but we use the term, kind of colloquially to say, oh, I have the right to express my opinion, and they call that freedom of speech. We know the difference, right? We know that's not really what it is. So what we're really talking about, do you have a right to express your opinion on YouTube? Well, no. Again, YouTube can determine what they want to have on there or not, but it does set a very bad precedence.
Well, for example, and I'm going to use a swear word here, Steve. I'll try to keep it a not really, really, really bad one.
Yeah, fuck off, whatever. Go ahead.
Okay, well, for example, I work at Walmart. It is actually part of corporate policy that if you say fuck in front of a manager, they can immediately terminate you. Even though it's your freedom of speech, the company has a policy against that.
Mm-hmm. They're not the only ones.
Right, but I'm just using that as an example. Mm-hmm. A private company that is not government run can impede all of your rights all they want, as long as you agree to work there.
You're a braver man than me to work there, man. Oh.
It's not as bad as a lot of people put off on YouTube, dude.
Yeah, I know. Actually,
well, I'm sure that's probably true.
But Walmart's not the only policy people that have that policy, right? But you're right, because you don't have the freedom of speech doesn't mean what people think it means, obviously, right?
Right.
Especially in a business environment.
It's just saying the government cannot impede your right to freedom of speech. Anybody else can, especially if you have to sign something to get hired and agree to it. With YouTube, you actually sign a contract saying that, it's the same way. They have the right to impede on your freedom of speech.
Can I show you guys just how you got to see this real quick. This is the absolute stupid shit that I got to deal with here. This is from Steiser. Will somebody read this off and make note of the fact that he fucked up the formula as well?
What's going on?
That's from Steiser in the group chat. Can you read that?
Oddly enough, no. Why is it closed?
I wanted to also add to that the government actually does.
Oh my God!
It does restrict free speech as well. If as a business you don't have unlimited free speech, you can't put a sign in your Walmart that says no black people or whatever.
Right. But the free speech was only to address grievances with the government without fear of reprisal. That's what it was originally for, right? To say, okay, I'm disagreeing with the government can't come after you for doing that. Now, there's been some interpretations of the courts of what that actually means, but it doesn't distill down to, oh, I can say whatever I want on YouTube. No, you can't. But hey, read what I just put in the group chat real quick.
Yeah, I saw that and I just said, oh my God.
Say, gentlemen, if I could have the floor, please.
No, hang on, Blue. Read this.
I'm actually, can I address that?
Yeah, read this real quick.
Stizor, that stupid limey fuck, that chav ball head.
Can I address that, Steve?
If you're gonna read it off first.
Okay. What Stizor has put up was, if I'm so fucking dumb, tell me why E = MC squared has no medium, you cunt.
It's actually E minus MC squared is what he said.
Oh, well, I'm sorry, I couldn't see that.
But so he thinks E = MC squared requires a medium. This is the level of incompetence that Stizer's at, and he wants to come in and correct us. No,
okay. E = MC squared has nothing to do with a medium because it's not dealing directly with the speed of light. It's saying what the energy to mass conversion rate is.
Yep. It's called that's what it literally is, the energy to mass relationship. It doesn't require a medium.
Right, I knew that. Yeah.
And you could say light requires a medium, but the thing is light generates its own medium. So it doesn't require anything like aether theory or anything like that. That's why Michelson Morley, when they didn't detect an aether, the prevailing model parsimoniously to be accepted was was special relativity. So
if I could have, at least he's correct in the statement that he's so fucking dumb.
Yeah, he is fucking dumb. Steiser. This is why I say I'm gonna allow you in, and then he does this stupid shit and he's going off of me. And I'm like, no, this is when I'm like, I don't want you in because now the conversation turns to Steiser, and I don't want that.
Well, he can't get in now unless he unblocks me. So
go ahead, Blue. You have the floor.
Thank you so much. Since we're talking about Satanic Atheist, I'll share the link with you. I would hope that those who can would give generously to the Satanic Atheist fundraiser. He recently broke his arm. He doesn't want to talk about it. You know, he's this one-armed guy making these great-ass videos that YouTube has pulled. So I'll send it to Steve. Steve, if you could be so good as to put the Satanic Atheist fundraiser in the chat.
I'll put it in the live chat.
Okay, thanks, man.
Just be aware, there's so many different fundraisers going on with Gus and everybody else, but I'll definitely put it in there. But you know, Saitan, you know, I asked Saitan to like sub me it wasn't even that long ago, and he wouldn't sub to me, and I'm like, really? That's fucked up.
Was
I
he
don't know if
doing
he was kidding or not.
religious parodies like that Dark Matter 2525 channel?
Yeah, similar. Yeah. I like Dark Matter 2525 stuff. He's got some really funny shit. See, I'm not a big fan of Saitan's videos, except for the operas, right? I don't get into the whole Muslim thing. I understand his thing, but I'm just not a fan of it. I do like his operas, though. Operas were brilliant.
Steve Stizor is now saying that photons have mass because it's part of the equation.
Well, they do have mass, but they don't have rest mass.
Right.
Yeah.
Oh my God.
So he's kind of right on that. Photons do have mass because of equals mc squared. That's right, but they don't have rest mass.
Please explain the difference to rest mass versus.
In other words, if a photon was not traveling at any speed, it would have zero mass.
But they have momentum, but no mass.
Yeah, they have momentum.
Oh, I see. Okay, now I get it now.
But see, the funniest thing is Stizer's never taking a physics course in his life.
Now, correct me if I'm wrong, but at high noon in Chicago, the city would actually weigh what, like 300 pounds more as a whole, just because of the. It's actually a proven fact that light actually does have inertia.
Oh well, yeah. Well, the particles do. Sure, that's how we have a solar sail.
Yeah, it's the same thing. It's just
Chicago's
Chicago's such a wide area, the whole city as a whole.
But the solar cell is not working off the photons. The solar cell is working off the solar wind.
No. Solar sail. We actually, literally, that is photons. What do you think the solar?
Photons, but I believe the way that they're using solar sails in space, because the force of the photons is so weak. I believe that they're actually capturing the cosmic, the cosmic wind, the solar wind, which is.
No, solar sails use photons. Guaranteed. It's called radiation pressure.
Yep.
And that's all photons.
Interesting. See, I thought it was.
That's also the basis that you can actually use. That's also the basis you can actually use lasers to compress things.
Yeah.
What is Stizor's level of education? How far do you go?
No idea. I don't care about people's level of education. See, I don't care about what their level of education is. I care. Have they ever read a book on this topic?
Oh well, that's why I'm so mad.
Look at Sean. Sean is a typical layperson who knows this set extremely well. Jade's a layperson. She knows it very well. What's that?
I mean, I don't brag about my IQ, but I literally am a living sponge for knowledge.
Yeah, no, I know, but see, I can tell when you're not. You're not talking shit. I can tell that when you say something, it's like, fuck yeah, Sean knows what the hell he's talking about. And we have experts in these areas that would point this out to you if you were talking smack, right?
That's why I like me. I'm being kind of conceited here, but that's one of the reasons why I like me is because I am a layperson and I can actually translate the science into a way a layperson can understand most of the time. Because I don't know all the technical lingo that makes scientists boring.
Yeah. Nathan points out that
scientists have a very hard time conveying information to the layperson because they're used to talking to other scientists.
Yeah, that's true. But Nathan points out that these solar sails do use charged particles. Yeah, of course there's charged particles, but solar sails they're called light sails for a reason, guys. They are really because of the radiation pressure, which is sunlight. So.
Yet I question who before Einstein said you need a eater. What is he talking about now?
Who said that?
Oh, Stizor did, but I'm trying to translate what he's trying to say.
Ether.
Stizer's so damn drunk right now that I don't think he knows what planet he's on.
It's not eater.
It's actually pronounced ether, but okay.
He's spelling it either. Only
no, that's how you spell it.
Yeah, it's pronounced aether.
Who before Einstein said you needed an ether? This implies that Einstein said you need an ether, which is actually not what Einstein said.
Yeah, Einstein did not say you needed an ether.
Okay, so we're kind of both right here, Steve. So if we're talking about a light sail, yeah, we're talking about photons. But because of the fact that, you get so little force out of even a huge sail, the practical applications, like I'm reading this article now, NASA begins testing solar wind sail technology which is actually using protons that are being ejected out of the sun.
Yeah. There's obviously charged particles that add momentum to it too. Sure, absolutely.
Which I think is a much, it only works close to the sun, and
Yeah, well, also you got to go by what's called your particle density, right? The particle density for photons is probably a lot more dense than protons.
Yeah, that's why a sail the size of Chicago would have about 300 pounds of force put onto it, just from light.
Yeah, somebody in the live feed also points out this should be said. Yeah, there was no such thing as aether theory, to be honest with you. It was a hypothesis that was Lorentz actually had a hypothesis on aether being the medium by which light would be required to travel through, because he looked at it as an analogy that waves needed a medium. You look at sound waves, you needed air. If you look at water, you see waves moving through them. So it needed something to travel, but we know a lot more about it now that the medium is actually created as the light propagates.
Now, I guess with the discovery of the Higgs field, it is sort of an ether in the way that you need a field in order for these particles to get mass, right?
Well, that's not that's not a field that things are transversing, right? That's a field by which
it's not like a field that you need for photons to pass through. It's a field needed to give mass to these particles.
Right. Through I think it's the Higgs mechanism. But I mean, it really doesn't matter. The point being is that when we asked this guy, Alan, to come in here originally, he was actually supposed to teach us about flat Earth. And none of that ever happened. And when we asked him anything about flat Earth, how does this work on a flat Earth, you saw the responses.
Well,
so I hope people
got the hangout last night on ED, or actually it was on Jared's channel, but Spur tried to come in and teach people about the flat Earth. And
oh my God! Oh God!
Yeah, the first thing he actually called me out or misquoted me from the chat, so I got invited in, and I debunked his first premise within 2 minutes, and even he had to accept it.
Well, that's a start. But I think what it is these people are so damn uneducated. It's so damn just not knowledgeable about these topics that they want to feel special. And I think that if it was true, they would be like, oh, look at us, we're the special people. We have knowledge that the other people don't have.
But why, if you don't understand special relativity, would you first think you do, and second, assert that you do, and right up against people who actually do know what it
Arrogance.
Is? Bizarre to me.
It is bizarre. And that's what we want to point out to people. I mean, but
the important thing talking with these flat earthers, I think you just have to stay on very simple topics that we can all observe. Like last night, when we were talking with what the guy was that we were just talking to here, I forget what his name was.
Valley.
He was getting into these inertial navigation and reference systems in the avionics, and I think the reason why they get into these arguments is, most people know something about how the sun and the stars move and things like that, but they don't know the nitty-gritty details about how these complex avionic systems work. So if they say, aha, you don't know how these avionic systems compensate for the curvature of the Earth as the plane goes around, basically turns upside down, right? They say, oh, therefore the Earth must be flat because these avionic systems don't have any way to adjust for that.
The number of veins.
Yeah, Schluter timing, yeah, exactly.
Well, again, I think they're so mentally limited that they don't have the capacity to really understand how things actually work, and they don't understand how reality actually is. So
they try to derail the conversation into these topics they want to talk about, and
yes,
in a way to try to get a gotcha. Like, oh, you don't know how these inertial reference systems work. That's a gotcha, right? And it's like, look, I don't know what I was telling last night is you don't need to know how these systems work to figure out that the freaking Earth is not a freaking flat, right? I mean, clearly all the evidence shows that it's round, so clearly these systems must have a way to compensate for that.
It's not just that. It's also the fact that, what a huge conspiracy and how much it would cost for, to pay for that. Not to mention the people you can trust who is telling the truth, and they're usually in a university, not in a fucking church. It's easy.
Well, somebody in the live feed, or actually my Facebook actually said something like, well, if flat Earth was true, why wouldn't all these companies use that type of navigation system? Because they would be saving a lot more gas because they would be traveling in geodesic lines, right? They'd be like, well, it wouldn't be geodesic, I guess, but it would just generally straight lines. But they don't use that kind of model. They use the model of a round Earth because there's a curvature they got to go over. If the Earth was flat, the distances would be shorter, and they wouldn't use so much gas. So,
Well,
it'd be business savvy to actually use a flat Earth model if it actually worked. But guess what? It doesn't.
distances would be shorter to a degree. After you pass a certain latitude, they actually become longer.
Let's see here on a high degree. Let me wrap my head around that. So
basically, because if you follow the disk Earth,
I'm looking at it as a chord though. A chord through the planet is going to be a lot shorter than anything that's going around on the circumference of the Earth.
Well, let's do the Johannesburg to Perth flights. On a globe Earth, they're about 8,000 miles. On a flat disk, it's like 14,000 on a straight line.
Well, sure, that's because the lines of longitude are diverging out from the center.
Oh, I guess it depends. Yeah, I guess it depends on the flat Earth model. Okay, I can see that. Sure.
If it was a square flat Earth with a Pac-Man style sun and moon, all distances would be shorter all around.
But I've never found out which of their model of choice, right? In fact, he didn't even have a model, which
I call it the Waka Waka model.
The Waka Waka. So it's like is that like the bicycle radial model?
No, it's literally a square map, or they'll even use the Mercator maps at some point. And they'll just say that after a certain point that we can't detect, the sun actually teleports to the other side of the map.
It teleports.
Yeah,
Wow.
that's why it's called the Pac-Man model. I call it the Waka Waka model.
Waka 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 and teleport to the other side.
Yep. And it's at an unknown line of latitude or longitude because we can't detect it because we pass through it and we're instantly on the other side of it. But
hey, we got Ad Blocker in here. Hey, buddy, how you been? It's been a while.
How's it going, man?
I get over to your neck of the woods occasionally, I guess.
No.
Over ED.
Well, it's boring over there, so I understand.
Well, I mean, you guys do kind of like sit there and just kind of like the same thing every day. I'd be like, At least we on the Great Debate over here on my channel, we try to get a little variety. I mean, in fact,
it's only 99% true empiricism.
Check. No, not at all. Man, in fact, what's funny is you'd be surprised how much we don't lately. Yeah, you're right, Quirks. But I will announce that we are having a hangout tonight at 6 o'clock. Alex Rubenstahl is coming back. If you guys remember him, he was the one that talked about dinosaurs last time. And he's coming back to talk about some of the new of the findings. And a lot of people are really excited about that because it was a really good guest. So hopefully I can stay awake for that.
one of the things you said earlier about his special relativity thing, Alibi, you said it was the dumbest thing you've heard on the internet so far. I think I can actually one-up you on that.
One of the dumbest, yeah.
I think I can one-up you on that from today, actually. It's actually to be featuring in one of my upcoming videos, and it's from Anthony Riley, of course.
Mm-hmm.
He decided to try to debunk Sly Sparkane's evaluation of the dog cam video. And he said he was going to do it with math called Pythagoras. But he wasn't going to use geometry because geometry is only made to support the globe.
So he was going to use the Pythagoras theorem, but not geometry? How does that work?
Well, since the Pythagorean theorem is actually part of geometry, it's actually one of the cornerstones.
Yeah, that's what I'm saying. How many people actually are just trolling the fuck out of you people over there? And how many people actually are literally this stupid?
Well, I mean, we had Spurs Chemo. We start going through the geometry and math with them and saying, well, this is just a construct. This isn't reality. This is just, something that just works on paper. It doesn't really translate to the real world.
As a fair tip of the hat, my next video that I am going to be working on tonight is called Anthony Riley Lies Again instead of Rides Again. And it's going to go over the past 2 weeks of all the lies that he's busted himself out in.
Yeah, well, I use that too. I mean, my video just had lies again in it too. By the way, has everybody seen my newest video?
I have not.
I'm curious, Steve. Who do you think is like specifically in the flat Earth? Who do you think is trolling?
Okay. There's several categories of flat earthers. You have the cons.
Mm-hmm.
You have the true believers that follow the cons. You have the trolls, and then you have people that just don't know any better.
Right.
They actually ask valid questions, and those are the ones that you can actually bring back from the brink of stupid.
Right.
See, I think. Okay, by the way, I put in the. Oh, that's not the link. I cut and pasted it. See, when it comes to people like Duranism and Orphan Red, I don't know if I fully believe that they actually believe their own bullshit.
Oh, Darren is full outright con.
Yeah,
there's no question on that.
I think so as well, right?
Orphan Red, I think she started out as one of the followers, and then when she finally got to the inner circle, she realized that they're in it for the money.
Mm-hmm.
I think that she's gone down that road.
It's possible. I could see that. Yeah.
Because earlier in her career, she didn't have that little high-pitched cutie voice. She developed that later on after she got really big into the flat Earth.
Yeah, so I think you're right. Because she was very dispassionate about engaging on this.
Mm-hmm.
And I think it's because that she knows it's complete bullshit, but she's getting views out of it.
Yes.
But I still have to treat everybody as if they're legit, because people, might take her shit seriously, and there have been people that took her shit seriously. So, I mean, I do want to work on more videos specifically against things that she's put out.
I will vehemently refuse to believe that Jeranism actually believes what he's spouting.
Yeah, no, I don't. No, I don't think so either. By the way,
I think Jeranism. I think you're right about Jeranism, and you're quick to come to that answer. But Jeranism doesn't come to UD. Like we mostly get the bottom of the barrel sort of idiots that actually do believe this nonsense.
Yeah, Anthony Riley, he's a believer, but he will definitely lie to keep his narrative going. And when you call him out on something, he will change his story just to make sure that he doesn't look like a total idiot. But he doesn't monetize anything. He doesn't try to ask for money in any way. He actually starts out as a true believer, and then when he gets busted out on something that he can't dispute, he'll say, "Oh, that's irrelevant now." Like with the whole flat runways thing, he says all runways are flat. We proved that they weren't, and that was the whole basis of his argument. Well, runways are flat, but planes still look like they disappeared, and he's always showing this one airport that has this hill in it. Well, as soon as we showed him what the topography of the runway was, he's like, "Oh, well, the runway's flatness is irrelevant now." But that destroys his entire argument, and he doesn't see that.
Do you want to hear the dumbest thing a flat earther ever said?
The Earth is flat.
Here we go. No, listen, trust me.
Why did the gods make the planets flat?
Oh. That's almost on par with geometry.
Writings and even the Christian Bible, the planets and the stars and the moon and the sun are there for our enjoyment. Nothing more. That's all it is. They're there for our enjoyment. That's it. That's it. Other than that, they serve no useful purpose, as far as I know. As far as I know, they serve no useful purpose other than for our enjoyment. That's it.
And yet we couldn't see most of them without
the sun.
Advanced optics.
Yeah, the sun is there for more than just our enjoyment, Von Helton. It kind of helps with food and stuff. Oh, God. And this guy didn't win dumb fucking version? That's the funny part. That's what's funny.
Version? What version of Von Helton is this? Is this the prior Mandela effect Von Helton?
This is post-Mandela effect.
Post-Mandela, okay.
Full gone. Bitch-ass Von Helton got his kids took away. Yes.
Because I don't want to accuse this Von Helton being.
No. I've witnessed all of his timelines. He was a stupid motherfucker in all of them.
In all of them.
Well, I was going to say.
So in every timeline, that's consistent.
Yes.
I was going to say you can't say it's pre or post Mandela because obviously something's changed. We must be in a different timeline now because this is a different one.
Right.
we're just not remembering it correctly anymore.
Yeah. Post Mandela effect.
As far as dumb fuck of the year, I mean, he's dumb fuck of all years. So, I mean, it's not like he's going anywhere.
Like I said, I've always said Von Helton has mental issues, though, I believe, right? So, I mean, I can't.
No, he doesn't. Lying.
He died. Dude, look at Pathological. I mean, he is.
Lying asshole is not in the DSM-5.
No, but delusional is. Clearly, if he thinks he's from another Earth, he's delusional.
Or he's using that as a way to validate his lies. Oh, no. In my timeline, that's true. I haven't.
Even if that's the case, then he's so pathologically lying. It's still a mental problem.
Well, look at it this way. There's an alternate timeline where he did win Dumb Fuck of the Year. So
there you go. Hey,
don't worry about
it. Good point.
Thank you.
Very good.
I thought it was that anything you can imagine, there is a universe for it.
Yeah.
That's not what the multi-world thing is, though.
I realize technically that is true, but I'm just saying that there is a theory a hypothesis, I should say, out there about that.
Who do you think's going to win this year for Dumb Fuck of the Year?
You know who's going to win. I just played you the fucking winner. Spurs
Chemo.
Spurs Chemo he's definitely in the running. I'll give him decent odds. I just don't know if
he'll be forgotten in 2 months.
Yeah, we got a long ways to go, right? And I think C. Brown is going to go the different distance, right?
Oh yeah, Superettes with the 3 pole star fucking flat Earth map. Yeah.
No, I said C. Brown, but Superettes is good too.
Well, Superettes didn't do well. No, he got in third last year, didn't he? Or
he what?
This year? Superettes got in third this year, right?
Yeah,
yes,
I think it was third.
Yeah. Von Houten and Superettes, if I'm not mistaken.
Well, I don't know, because Anthony Riley's making a public face because of me and Splice Barcane now, so he might actually be in the running this time. I mean, because he's pulling out some real dumb fuckery, and that he's gonna be like my next 2 to 3 videos. And it's bad.
Well, since Steve, no, there are no rules in the voting, so I can't accuse him of playing dirty. But the fact that there are no rules in the voting we're not letting what happened with last year happen.
But anyways, I didn't really break any rules, which by the way you can do.
You can't do no. He just all his people on Facebook and all his old medical students and told them to vote.
That wasn't me. That was Lamed's student. Lamed's student got all those medical students. But I did put it all over Facebook. Yeah, no, I campaigned for him, no doubt.
Oh yeah,
and by the way,
for him a lot.
Oh, I did. Oh, yeah, but you know what? I said I was going to. Wasn't like it was a big fucking secret, right?
Well, I'm going to give you guys.
But I mean, even Red's agreed that he definitely earned that. But whatever.
I'm going to give you guys a treat privately. Turn your speakers on if you watch it because it's got music that is copyrighted that I actually have permission to use in my videos. From the actual.
I don't want to play it in here though.
Well, no, that's not. This is a treat for just you guys alone. It's a preview to the intro of my next video.
Are you linking it or playing it?
I linked it. Well, forgot to hit enter, but I'm linking it so you guys can watch it on your own time. Or if you watch it now, just make sure you leave the speakers turned down, or make sure it's not going to be playing through it because it does have copyright music.
Yeah. There you go.
Yeah, that's the intro of my next video for Mr. Riley.
Yeah, I've seen him on. He was in some flat Earth thing not too long ago. They kind of all hang out in this one channel. I don't know the name of the channel, but I think he was in there, but they wouldn't allow anybody in the live feed to even mention anything about not flat Earth, right? I mean, if you're a non-flat Earther, you just ban, right? It's like they limit their exposure to people that can disprove them because of them, as you said, this is a money-making thing to them. So they don't want people being talked out of it.
Right.
Yeah.
And I think that Riley is, like I said, I don't think he's in it for the money because he doesn't monetize anything. He doesn't do anything asking for money. So he's just that stupid.
That's pretty sad. At least the people that are doing it for money, at least I can go, okay, they're dishonest fucks, but they're not completely brain dead. If you're just a flat earther because you believe it, you are fucking brain dead.
But the part that's got me confused though is why, after he gets called out and shown something, does he have to do a 180 and just start making up things on the fly to keep his narrative going? I mean, it's just so blatant that even the flat earthers are calling him silly. Political Hillbilly outright called him silly for the things that he says.
But it's an attention,
and that's Antonio's buddy right there. So he's already getting kind of ostracized by the flat Earth community because of the bullcrap that he's trying to pull off and getting caught at.
Hey, never mind. I put the link to that fundraiser in the live feed right now. By the way, I just
Thank
saw
you
it.
so much. Yeah, hey everybody in the live. Those of you that can help out Satan, man. God damn.
Has he even said anything since? I mean, has he said what he's going to do, or?
He has the new account on Minds, which is on my video, which you can link to, whereas some of his videos are, and there are a couple Satanic Atheist mirror channels, and Atheism TV had the old videos, but I mean, people are like, yeah, everybody's talking about Satanic Atheist, but no one's helping, no one's giving money, and sometimes that sounds real base or real rude to say, well, please give us some money, but that guy has certainly earned it. As much as I've laughed over side, and I agree with you, Steve. I mean, it's the musical ones that are just absolutely priceless.
Right. Yeah, they're priceless.
I mean, we should go back we should get that Voyager record and bring it back and put Satanic Atheist songs on it.
The Rhapsody, the Bohemian Rhapsody one.
Bohemian Rhapsody, the one he did about
that's one of my all-time favorite. I gotta admit though, that is one of my all-time favorite videos. It's just that good.
Oh, I am in the Bohemian Rhapsody, as you know.
Yeah, that was before my time, or I was just barely coming on the scene back then. Like I said, Satan, I don't think he watches my stuff, or at least a year ago when I asked him to watch my stuff, he didn't. But I don't know. But by the way, Antonio Fletcher's having a hangout, by the way, right now. But it's on abortion, and I don't know how many. I was like, really? Live debates on atheism and abortion, number 6. Like, nobody wants to go into his room besides Hillary.
Here, let me explain it to him. I hope he's watching. Here's how it is, Antonio.
He's not watching. He's having his own hangout. Nobody wants to join. There's 5 people watching.
Legal and rare. That's the goal. Abortion should be safe, legal, and rare.
Yeah,
I don't know which Bill Clinton speechwriter thought that up, but he or she deserves credit because that says it all.
Yeah, no, I agree. I mean, I don't believe in like third-term partial birth abortion, but for people in the first trimester, yeah, whatever. Fuck it. You need to have it available.
Well, that was the. Well, this is just a.
There's really no
scale, but
there's really no reason to have a third-term partial birth abortion unless it's a severe case of the endangerment of the mother. But even then, there's the alternatives that they have. So I mean, I think it's.
Well, the old school rule was the quickening. The old school rule is the quickening, because before that, ethically it's okay, and after that it is not. That was how they dealt.
Yeah, no, I know that.
When is the quickening? It's like what? 5 months? 6 months?
No, I thought the quickening is when the baby took the first breath, wasn't it?
No, I'm just saying that there used to be a myth, a practice amongst people who actually did abortions, old school abortionists, and handed out these weird chemicals back in the day, that it was ethically okay to do it before the quickening, but not after.
Yeah, I guess nowadays it basically means when they think the fetus is viable, or when it's first kicked, or signs of life, which was usually a kick, right?
And that is when, like the
13 to 16 weeks.
4 months.
Yeah, that's 4 months or so. So yeah, that sounds about right.
Oh well, that's the
P.Z. Myers. We're gonna ask when he's in here, but the point being is that he has these hangouts. Nobody wants to join him anymore. Nobody even wants to watch him anymore. There's like 9 people watching, and basically one of them is RSC. Get the fuck back over here, RSC. But it's just, I feel sorry for Antonio. He's killed his fucking hangouts. This is why I have 100 people watching. He has 9, and we know most of the same people. But I'm going to be terminating this soon. But I do want to point out real quick. I went on TST the other day, and I thought we had a resolve with Ronnie. I guess I was wrong. Go figure. He so far he hasn't kept to what I thought the agreement was. But I'm going to give him like to the end of the day. But then if not, I'm going to put on something tomorrow, expressly saying that he just can't. Well, I already know he can't be trusted, but I mean, this is kind of bullshit that I thought we reached an agreement, mutually agreeing with all sides through third parties, and he hasn't lived up. He hasn't kept up to his end of the bargain yet. So, not surprising, right? So I think I'm going to do is I'm going to make more videos pointing out the lies from these people. And unlike them, when they say, "Oh well, we're going to make lies exposing exposing Steve and JD Kane and Dragnaut and all these people being liars," and they never do. When they try to make a video, backfires on them because they actually lie to try to say that we're lying. I don't have to do that. I can make videos that are actually spot on and show very clearly that there's been lies on their part. And I think I'm going to make more of those actually. So,
well, I mean, that's very rewarding. You just play a clip of Jason Burns or G-Man or True Empiricism, lying their ass off, and you stop the clip and say, "Hey, you're a fucking liar. You have no evidence. I wish you'd go fuck yourself."
Well, G-Man is pretty easy because G-Man, he doesn't even have to lie. He just stretches the truth to the point of it breaking kind of thing. He does it for entertainment. That's it. He doesn't care. So you can point out G-Man's lies all day long. It makes no difference to him because he doesn't give a shit. He knows he lies. He knows he's full of shit. He does it for entertainment value. I get that. But other people like True, people actually buy into his bullshit, and that's why I make videos pointing out his deceptions, because he lives literally in bizarre world. Up is down, right is left, cats are dogs. It's whatever you think is right, he's going to take the opposite position. Whatever you think is normal, he's going to think is abnormal. It's surreal. Like the whole thing was, he thought it was okay for him to take my entire video, but thought it was not okay for me to take snippets from his. And you then do a transformation piece. Who thinks like this, right? I mean, it just makes no rational sense. But like I said, I thought we resolved it. I guess I'm wrong, but I'm going to give them to the end of the day, and we'll see what happens. So, because if not, I'll talk about it again tomorrow. But anyways, tonight, 6 o'clock, Alex Rubenstahl is going to be joining us to talk about the newer discoveries of dinosaurs. I haven't been feeling well yesterday and today. My voice is kind of shot. If we do have this, I might just start off and have Jade take it over, because I know she's really interested in this, and a lot of people like the dinosaur stuff. So I might have her just do my hanging out for me tonight, if that's possible. We'll see how I feel. But anyways, you guys have any closing thoughts on this?
I want to know why Anthony Riley looks like he got stung by a hive of bees.
Oh, come on.
What a jabroni.
Sarah, is there anything on? Any of you guys got announcements? Anyone want to plug your channels? Do it now.
Looks like. No, he really did get stung by a hive of bees. What are you talking about?
Oh, you really did? All right. Tune into Earth Discussions, 24 hours worth of nonstop excitement.
There you go, Earth Discussions. I like that channel. I do go over there often. So yeah, I put shouts out to you guys.
Yeah, somebody unbanned me from Earth Discussions. I won't threaten anybody.
No, just no. Why do you have Blue blocked? Yeah, what's up with that?
I didn't know he was banned. Why'd you get banned?
No. It was fair. Somebody was making a joke about Sandy Hook, and I lost my temper.
Yeah, I'll unban you, Blue, but man, try to keep it in your trousers, all right?
Yeah. All right. I want to thank everybody for joining us. Tony, thank you very much for joining us. Sean, always a pleasure, my friend. Quartus, you're awesome. Sure, so you get a chance to talk, but your mic was shit.
I went and picked up a new one. So
and now you're normal.
Cool.
Blue, I don't even know what to say about you, my friend. And Adblocker, is always a pleasure to see you again.
Oh yeah,
love your channel over there. And you're one of the admins or whatever it is. So everybody, thanks for watching. We had 120 some odd people.
Thank you, Steve.
You're welcome, guys. And I will see you guys tonight.
All right.